Yeah, that's right.
That's okay.
So the YouTube stream is starting. And then later, like we'll be able to refer to this. I just want to try it as an experiment to see
Yeah.
if this becomes useful after the fact.
Yeah.
Oh, so you're going to record this then?
Well, it's just streaming out to YouTube, and I was recording a few of them before.
Okay.
But that. Oh, that's my YouTube stream. It's got me talking again because it's a little bit behind. I just shut the sound off. But I was recording them before, and the difficulty is now I got to store them somewhere, and then I got to maybe edit and upload them somewhere. And people eventually asked me for the stuff, and it just turns into like work all the time. So I just thought, well, if there's an interest in having recordings, why don't we just stream out to YouTube, and YouTube takes care of it. And if we don't like the streams at the end, we can delete them.
Sure.
Anyone can download the stream from YouTube if they want and edit it or do mix and match.
I'm curious, Darcy. I didn't streaming to YouTube. My understanding of YouTube. The one time I used it was I simply created a video and then uploaded it to YouTube, and that's the end of it right there. What's with streaming to video to YouTube continuously?
It just means that what we're saying now, there's a YouTube video that now exists as of 1 minute ago, and we're on it.
Oh, wow. Thrilling.
It's live. It's a live YouTube.
Interesting.
Now, the real question is there any ads running in front of that?
Yeah.
I doubt it. It's because it's like the YouTube channel doesn't have any traffic. It has 5 followers.
Shoot the rabbit. Shoot the rabbit.
I'm just posting it on the event page now, the actual link to the stream. So if you want to see what you look like in YouTube, you can do that.
Yeah.
I'm just posting the link here. I think today's going to be a big party.
So Greg?
Yeah.
Those are yours.
Oh, okay, great. Thank you, Doug.
It's coming. I realized I can't count, but I took the pieces you sent me and I said, well, this is cool. I wonder how they fit together. I said, but there seemed to be not enough of this piece to fit in the 4 holes. And that's because I only cut one of them, but whatever. That will be fixed.
Yep.
Yeah, a little slow.
That's okay.
I like Lakota's thing. It's LG, like life's good.
Well, those are my initials.
No, I know that. I just think it's like iPad
I get it. It's
or
Lakota. I get it.
Yeah. No, I get it. I thought it was kind of funny because when I first looked at it, I thought it was like people coming on their iPad or whatever.
That's true. There is a phone brand named LG. So
yeah.
Yeah, a big one.
Yeah.
And TVs too.
Yeah.
And a lot of other things.
I'll show you what our YouTube stream looks like here.
Isn't this going to be like putting 2 mirrors together?
Yeah, the universe might explode. Be careful. So there it is on my screen. It has one watching. I believe that's me.
Oh,
so
it's delayed.
If that number goes up, that means we have like someone actually watching what we're doing.
Uh-oh.
Pretty exciting,
okay.
eh? Oh, you see, it's behind. See, it took a minute. So when I unshare this, it'll eventually revert back. If you wanted to share it with someone, you could go on your Facebook and post this link. And I'll do that right now just for the fun value. I'll just take this link here, copy it, go to Facebook, boink. I better minimize there or maximize so I can see my Facebook.
Mm-hmm.
And I'll post a link and see if people join the link. That way, these people won't be able to contribute though, except for chatting in YouTube.
Mm-hmm.
But party there, paste. There it is.
Hey, Olaf.
Hello there.
I haven't seen you in ages. You've probably been doing all sorts of cool things, but
no, actually very little and not very cool at all. So I've never done the Zoom thing before on this platform, so I guess I'm coming through, so that's good.
Yes,
Yep.
so that's
Yeah.
Yeah, we can't see
Hello,
your video
folks.
though.
Yeah,
You might want to share your video if you have it.
I don't really have a camera.
Okay.
That's code for I'm in my undies.
My man jammas.
Yeah.
Is this the first time you've joined us at all on our Zoom meetings?
On Zoom meetings, yes, but I've been to a few meetings in the past in fits and spurts.
Yeah.
But physical during the days when you'd actually have physical presence. You meant when you actually went to the library.
No, yes.
Yeah.
Oh, okay.
Yeah.
A few times there, and then Makerspace North, and then what is downtown.
Yeah.
Actually, what we've discovered, we've been doing this now, I think, for about 3 or 4 weeks. We discovered that this actually makes a better makers meeting than it does face to face, because we all have our computers to do screen share, and so much of what we do is quite often on our computers that we found this probably we may not go back to back to a real physical meeting again.
I still want to go and play in the park, because you can't launch those water rockets in the house. They're just, you get a mess.
Yeah, it's terrible.
And Darcy has a brand new generator so that we could actually have a CNC party in the park with the generator, and there's enough power to run a laptop and a computer and all that jazz. So
probably the first one ever.
Yeah, possibly. We did try to do that a year ago, but we couldn't find an AC outlet.
This fucking thing.
Somebody's having technical difficulties.
Yeah. Okay.
1, 2, 3.
I guess the parks don't come with AC outlets, do they?
No. Well, the government took them all away, so that people didn't charge their cars or something. Yeah.
Well, I see Eric Dormer there. He's been out too. I wanted to just mention, because he's got one of the machines we're going to talk about later today already. He hasn't gotten his running yet. So I invited him along thinking, he's already built his, just like I have, but a lot of people who have machines might want to join into this, because I'm going to try and get people started on the machines myself. And I'm sure other people in our group are going to try and run workshops and whatever it takes to help everyone get going.
Yeah.
Something I have.
We don't hear you, Eric, by the way.
Yeah, I'm struggling.
Okay, fine. We hear you now then.
Oh, you heard me?
Yeah.
Oh, okay. I got the world's worst little USB sound ever.
Sounds okay from here.
So yeah, I was actually looking at possibly getting one of these machines before I decided on upgrading my workstation instead. But the reality is I don't have anything that I immediately need it for. So I just, like I said, I updated my workstation instead, but that took all of my disposable income. So I'm just here in a voyeur mode.
Yeah, I'm
use it to make
pretty sad if you're voyeuring us.
I live a sad, sad life. I admit it, really.
I'm going to go ahead. I'm going to follow it with interest, but I don't foresee right now getting a machine. But I'm interested enough to follow it. Is the first get together at 1 o'clock tomorrow?
First get together what?
For the CNC thing.
I don't know.
No, we're doing lockdown's not clear. This is the get together.
Oh, yeah. Okay, that's good.
Yeah, but that's later, right?
Oh, yeah. Okay.
I think,
but there might be another one. I haven't checked my email. Just a second. Oops, it goes to me again.
Well, and Darcy just walked away, so he's off for a minute. But
okay.
I think, yeah, we were going to do our regular meetup thing at the beginning, and then segue into the procurement stuff of the CNC machines.
Okay.
So so that people had some vague idea of what it is that they were looking for and what are the details and stuff.
Yeah.
Which is cool.
According to the calendar, it's around 2:30.
Yeah. Okay.
And Isabel says she's going to be a little late.
Yeah. So.
Are you telling me there's actually a timed agenda to this meeting?
Well, it's not. No one's going to enforce it because I can make all the agendas I want. And so can anybody, but then somebody has to try and enforce it without getting beat up. So, you know.
Yeah.
Mhm. Well, it's harder to beat you up now that you're virtual.
Yeah, it's a lot harder.
I don't know. You could Zoom bomb them, you know, just come in from the side. Yeah. So
before we get serious, I got there's a, you know, people are sending me crap all the time, but I normally don't show it to people. But this was kind of a clever one. Lakota, I think either you're gonna find this very funny or slightly off color. But let me take the risk. Okay, hold on. I'm gonna do a screen share. Oh, you've disabled screen sharing.
Oh, have I? No.
That's what it says when I hit screen share. It says host disabled participant screen sharing.
Yeah.
Well, yeah, you have that stuff that you want to show it.
I've done that by accident if I have done it. Screen sharing, advanced. Oh, it just says one participant at a time. I'll put it on multiple and see if that helps.
Okay. Got that?
Yeah. Is it working?
Oh, well, okay. Well, we got it's that's we've got it. Hold on. Here we go. Okay. Here. So here, this is the video goes on about 2 minutes.
Ouchie.
Oh, it's one way to scare.
Let it go.
It's one way to scare away a creepy guy.
Yes, exactly.
What if it
Yeah, she's
doesn't
walking in
scare him?
circles though. She turned 4 corners.
Yes.
There you have it.
We seem to have a pause, so maybe I'll ask a question. I'll even make a true confession.
Okay.
I actually have one of the CNC machines that I'm talking about.
Hello, Eric.
Darcy, hi folks. Darcy got one a little after me. He helped me kind of sort mine out, and he said, that's a pretty good machine. I think I'll get one of them. So then he did. Then he assembled it, and I think he's been using it and everything else. I have yet to mill my first items. It's a lot easier to place an order on eBay. And even then you got to assemble it, and that's not trivial. And then after that, you got to figure out all this software to make it work. And that's quite intimidating, I find.
Yeah.
Yeah.
We're here to help you.
Yep. Well, I think it's going to be a fun party because, you know, when we get to assembling things, we can sort of watch from afar and we can ask questions and say, I'm missing a part. This is why it's not going together.
You better hope you I see there's a go faster button on Zoom. That'd be really useful.
What materials can this thing work with?
Well, from what I can see, it's mostly good for milling plastic, but which is great. I'm an electronics guy, so for me, it would be mostly, you know, cutting holes in enclosures or maybe making a special mounting bracket, that sort of thing. I also have a 3D printer, and I've used it for one or two little things that look like Yoda and Star Wars characters. But other than that, I wasn't impressed with the physical strength of those, like the mechanical structure. Whereas I think the 3D CNC milling machines, you end up with actually a usable part. So it's an entirely different animal.
So one of the interesting things Darcy and I have been talking about is Fusion 360. Ray pointed this out. Now supports Eagle, which means you can do schematic design there. And it may be possible to, well, it certainly should be possible. I've seen videos of these small machines being used to cut PCBs.
That would be
using a V-carve. Now, you're not going to get the same thing you get when you order a printed circuit board from China, like 6 weeks of waiting. or those exciting features and double-sided. But if you can ignore that or forgive those little details, you could do some pretty rapid prototyping potentially. So
yeah.
For
all certain things, I think the CNC milling of a PC board is okay. Very simple circuits.
Yep.
But I'll tell you, it's tough to beat the so-called 6 weeks. If you pay the $35 for whatever the courier,
it
costs you $40 for like 10 boards, each
I
which
know.
10 centimeters, 10 centimeters, two-sided. I mean, what do you want? Like, it's the shipping's the biggest cost. They're $1 a board. Other than that, it's ridiculous.
I understand, but the distinction that I make is once people get these machines, one of the things you can do is, without knowing anything about electronics, and you can actually experiment and play a little bit, and then you can start committing to it because you actually get comfortable with the design.
Right. It's a rapid turnaround. In other words, that's the real value.
Yeah, and being able to have some proof that what you're thinking about is actually going to work, and that you can actually use surface mount components and not pull your hair out or through hole components.
So I don't know about you, Doug, but often I do that proof of concept on like one of those little proto boards, with all the little holes. And that only works if you have 3-hole components and stuff, then it kind of works.
Yeah, I work with those.
Yeah. You Duncan, sorry?
Yeah, I've done some stuff with those like little like the little prototyping boards with all the holes.
Yeah. So now you have
they work fine as long as you're not like trying to do RF stuff or something at super high speeds or whatever.
Perfect.
It kills it if you're trying to run too fast.
Dan's got one there.
If you're trying to do components on those, it's a pain.
Dan's got a whole bunch of them. My desk is covered with them.
So Dan,
what do you call those boards? Sorry to jump in, Doug, but what do you call? I never know what to call those whiteboards. What are they called?
Proto boards.
I thought they called them breadboards.
Yeah.
Solderless breadboards or proto boards. Yeah.
This is what I think of when I think of a
breadboard.
Breadboard. It's copper on one side.
Exactly. Yeah, that's what I think. Okay. I got about a dozen of those in the basement too.
I got one here. It just says PC board.
Yeah. One of the problems is we all have a different name for everything, so we all know what we're talking about, but we don't agree.
Yeah.
This one's just from Gervais. I used one of them in this thing. It's a speaker protection box.
Yeah.
What does it protect?
The CNC machine could be used for, like, if I can make just a couple boards or something to make sure that I have my layout down. And then once I have that and I'm sure of my design, and I know maybe even a couple people want them, then I'll make 40.
Yeah. One place where the CNC milled PC boards would be good is if you're doing power supplies. You typically want big wide traces anyway, so then it's fine.
Yeah.
Well, there's such a thing as laser tape, and you could just laser off a pattern and then just use the ferric chloride to.
I wasn't trying to. I wasn't trying to rat hole us down using it as printed circuit boards. I was just saying it is one thing. Darcy has a beautiful print a block print he made the other day, which is awesome.
Oh,
Did you show that one, Darcy? Most of them didn't see that and this is a really beautiful block print, quite within the realm of what you can do on this, and it's cut in cherry, I think was your wood.
Yeah, and Duncan was talking about materials too, and I'll go get the block in a sec. But I have a question: how much time do you have?
That's
so you
true.
can, in theory, cut any material if you have enough time. But these little machines are probably not going to be your first choice for cutting anything metal. But I bet they'll cut aluminum no problem. Talk to Doug about cutting aluminum.
Yeah, if you could mill some holes in one of these, just a thin aluminum enclosure.
Yeah, you can. The trick is you have to go down ever so slowly. So you're just taking I have a process that can do that. You just cannot, because the machines are not rigid enough, you can't go deep or they'll vibrate. And if they vibrate, you'll break your bit. But you can get by, and that's why I said if you take your time, you can cut pretty much anything. Not steel. I don't think you're going to cut steel. It's not likely.
Is it taking up, if it takes a while to cut something, is it taking my time, or it's just the machine that's sitting there?
Machine time.
Here's a question I'm going to throw out. Suppose that I did have to mill steel. Does anybody here have experience, or even brass or tougher plastic? Does anybody here have experience using, I presume there's a service bureau, someplace you can send your CAD files and, they'll make 10 copies of part X.
Is that called the Doug?
Yeah.
Pardon me?
You can rent
the service bureau, Doug.
Yeah.
You mean for steel though, right?
Well, I'm just sort of saying, suppose I need, I've made one and it's sort of, okay, now I want to make 10, not 1,000, but 10 of something. I still might want to ship it off to a Service Bureau, AKA Doug, or maybe there's an equivalent to Doug. Not as good, of course, but something.
There's China. A lot of the PCB prototypers have additional services which are variable. There's first choice prototyping. They do all sorts of things. They'll make molds for you. They'll do small parts.
Right. So for clarity, I'm looking for something that might be, Montreal, Toronto, Ottawa, that area. In other words, not shipping to and from China, like something pretty close that's good for quantities of 10. 10
well, pretty much
brackets.
any machine shop will be able to do that.
Yeah, exactly.
Wasn't there a maker group out at the train yards that was renting the big machines for like really good prices?
Yes, there is. That's Prototype D, but I don't know what they're called now.
Yeah, so that we have for prototyping and that kind of thing, there is a group in Ottawa, and I forget the name, out by the train yards, and they were advertising some incredibly low prices.
They even have a water jet cutter that'll cut 7-inch thick pieces of aluminum.
Yeah, that was amazing.
Wow.
And it was moderate prices too.
That's cool. Good to know. So Prototype D or something, you thought, eh?
It's the Bayview Yards, and I don't know
Google
what
it right now. I'm going to Google it off to the side here.
I don't know what else it was called, but they're a pain in the ass to work with sometimes. That is figuring out what they're doing, but whatever.
Is that an administration thing or a personality thing?
I don't know. I can't distinguish.
There it is. It's called Prototype Lab Ottawa and Bayview Yards.
Yeah, that's the one.
They're called BayviewYards.org.
Yeah.
I could do something like that for this thing because I've like it's a speaker protection box to save speakers from BC, and like a lot of amps have it built in, but I work with a lot of old ones that don't. And I've designed this thing and built a few of them, but between cutting all the holes in the box by hand and making the circuit out of those prototype boards, I can't make them profitable. But if I've got a way to just have a bunch of these boxes cut, because this is just a standard Hammond enclosure.
Yep.
If I can like get 10 of them cut and get some boards printed, then all of a sudden it's a lot more worthwhile.
Yeah.
Oh yeah, for sure.
So Darcy, do you have that print?
So here's the print that Doug was talking about. So these are blocks that I carved, and these are just little pieces of cherry plywood, and I've carved in this with a CNC machine, and this little cutie I just made just the other day, kind of for this presentation because I could show it off. Because you can make this whole assembly on one of these low-cost type machines that I'm going to talk about a little later, during that section. But I'll bring my my cam over here to my CNC machine. You can see all the cards that I made out of this thing. So
You're mass producing porno here, Darcy.
Exactly. So this is like my
well done.
Mother's Day card. This is my Father's Day card. And I made them a bit generic so I can print more of them and use them as like thank you cards. Like if the pandemic ever ends and I go to a house party, this will be my thank you cards. And then all these little tiny ones are really small. Excuse my hand here, the rough size of this stuff. And this is so you could carve, any of this stuff you're seeing here, you could carve on one of these little machines. And of course, then there's circuit boards and whatever else you can dream of.
Those are pretty nice results. Like you're getting, as long as you control the cutting speeds and stuff, you can actually get really good results. The other thing is this plastic is awesome. This high density polyethylene, it's softer than wood. It has no grain, and you'll have no problem cutting things like that.
So Duncan, I was thinking about your boxes. Instead of getting them all done individually, why don't you just get one, seeing how they're all identical, just get a steel die cut using those guys at Prototype D or whatever. And you're cutting into aluminum, so a steel die would punch the pattern into aluminum, no problem. And then you could just make as many of them as you want.
I wouldn't debate that. Like for a certain number of size of a run, a die is going to be a good choice.
Yeah.
But I think people who are into the CNC are looking to be able to make ones as well.
Yeah.
And that's where the die, you need a larger number and you want to be able to change your design. I remember when I was doing a business to make rubber band airplanes, they've been die cut traditionally for decades and decades. But I thought, well, if I commit to a die, now I can't change my design without paying money. So I went against all the grain and I decided I would laser cut my design so I could revise it anytime that I wanted to. And I wouldn't have to do any large runs. I could only do the run. Anyway, I didn't mean to poop on anybody's answer for that, but
yeah, well, could you laser cut aluminum with a small CNC?
I don't think so.
No.
I think
No?
you need some higher power for that because it
No,
conducts
the other thing about
heat
aluminum
and
is
electricity really well, and you need a lot of horsepower to come at it, I think.
Yeah, aluminum is very reflective for the CO2 lasers.
Oh, there's another problem right there, yeah.
So
Yeah, you need you need a YAG laser to do this. It's different color, different, like there's a whole bunch of things. This is not for home use, so none of those little diode lasers are going to even touch that.
Because of danger.
Yeah.
Yeah, danger, Will Robinson.
That's right.
There are a couple little variations I've done on this thing, but they're all based on like the connections at the back. They're just like the standard IEC and power cord connections, and I've done like a couple of different configurations. So it's all built around standard parts anyway.
So there
that's
is
pretty thin aluminum, though, isn't it? You could probably mill that pretty easily.
you can definitely, but there are other options as well. One option, which could be fun, is printed circuit boards. So not you making them, but letting China make them for you. So they have part of a printed circuit board is machining the shape of the board. So if you put holes in it that are the size of all your connectors and switches, you can put silkscreen labels on what they are. It's all pimped out with colored PISM, and then you bolt that on the face of your or the back of your thing.
So they're really making a panel. They think it's a circuit board. You think it's a panel.
Yeah, and you can get different thicknesses of the material as well.
That's genius, Doug.
And yeah, it can look wicked too. So then you're just anyway. There's lots of ways to skin a cat.
That's a really smart idea. I've never thought of that. That's a great idea.
That's cool. Yeah, there you go.
Another good.
So that's a ruler.
To use acrylic.
Yeah, that's a ruler. That's actually a printed circuit board. So
I have one of those too.
Yeah, this is from AVE's
Yeah.
YouTube channel. So it's got a magnifying glass in there and an LED, so it and a magnet and stuff. But it is basically just a circuit board. Cheap,
So Doug,
super
you're suggesting like having just like one big cutout for the back of the box, and then just stick
and then just slide in a circuit
potentially,
board.
yeah.
Right.
Yeah.
Bolted inside.
Bingo, Bob's your uncle. Cheap,
Yeah, and
too.
these are fiberglass. They're super tough, right?
Yeah.
So they're maybe as strong as the aluminum.
That's a great idea.
And anyway, the other interesting thing about that is if you want to get really creative, you may have circuitry on one side of it too, like
surface mount, of course. Yes.
like well, not even surface mount, but just maybe surface mount, but you just want single sided, like on the inside, and then the connectors on the outside.
Yeah, the point is you don't want the hole to go through. You'll electrocute somebody on the other side.
Well, potentially, yeah. If you put the 110 volts on it, it's a special feature.
I've got all little holes on the bottom. I've got to get all these holes drilled too, and I've been like measuring them out and with like green tape on the bottom, measuring them out and then drilling each one individually. That part of it's pretty tedious too.
Duncan, I'm questioning something. I must have missed this, but what does this marvelous box that you're building do?
It's
Well,
a
nothing really.
protection box. So I work with repairing a lot of vintage 70s home audio gear. And any amp you see today probably has a DC protection in it. So it has relays that shut off the speaker as soon as there's a problem. But there's some older amps that don't have that. And if there's a problem, it'll fry your speaker. Like if your speaker suddenly gets hit by 40 volts of DC. So it's just basically that circuit in an external box.
So it's a circuit protection for speakers so you don't toast the speakers.
Yeah.
Okay.
Cool.
For a few select amps from the 70s that don't have that already.
So I also wanted to mention, Duncan, I think you get the award for the best backdrop. I'm very impressed with the northern lights and the sunlight peeking over the earth, but you actually have a shop that looks like like my basement. So I can identify with you.
Oh, perfect. Doug's got your answer there.
There you go. I have 110 volts and the circuit board on the face of my power supply. So,
wow.
And that's a 3D printed plastic.
But wait a minute.
To cover that up.
Like, are there electronics on the outside? Wouldn't that hurt somebody?
No, I wouldn't hurt anybody.
But
so the 110 volts goes to the power brick internally, totally isolated from this. That's just a physical carrier. And then I bring 5-volt jumpers to the back of this that does all of the other stuff that I wanted. And then I have my connector. So there's only 5 volts on this.
Oh, so the
piece of it.
traces I see, I'm just looking through the red fiberglass to see the traces.
Yeah.
Okay, now I understand.
But you can, I don't know, it's hard to tell with the glare, but you can see that you get nice silk screens and a kind of a cool looking effect. So I've been playing with this as an idea for a while, and I just think it could be a lot of fun, especially depending on how you design your little your product.
Doug's, do you have standoffs behind that, or is that bolted directly to the plate?
No, it's I have multiple well, this piece of plastic actually has thickness, so it's not just here, it actually goes deep into here. So there's a window around here. So everything here is bolted into the frame. And then it's hollow in the middle, and then it's bolted in here as well as in the bottom. Oh, sorry, in the bottom.
Okay.
So yeah, there's lots of strain relief. That connector, it's so heavily backed, you could hammer at that, and I think you'd break the connector or the switch before you'll break the rest of it.
Can you hold it up again for a second?
Yep, no problem.
I'm just trying to configure the screen thing so I can actually see.
Yeah, if you pin that video temporarily, you get it.
Did.
Yeah.
Oh, I'm sorry, Doug. I must be slow on the uptake, but I'm looking at the back.
Yeah.
And I guess I don't understand because I see what looks like circuit components. Are they on the outside? Like, could I touch them if I use my finger and went up to it?
You can touch them if you put your finger on them. Yep.
But Eric, that's 5 volts.
That's 5 volts.
Even so, you don't want to brush it up against somebody and knock off a component. I'm a little curious.
But this isn't a consumer product. This is, you know, could be integrated into something.
Yeah.
Okay. I got you.
So,
all righty.
Yeah, exactly. This is not a consumer product. If you want the consumer grade product, you want my other variant of it. There, that's the consumer grade product. But I still am not happy with this thing coming out the side, but I just haven't put the edge plate on it.
Yeah.
So, and then.
But I like your earlier point, which is in principle, you could use a good tough PC board. You could cut holes in it for sockets and stuff, and you could put active components on the inside as long as they were surface mounted, not through hole.
Exactly. And
yeah, that works.
So
that's a great solution. I love that.
This is the same concept as the black piece that I had here. So this is going to slip over the face of so you get your AC connectors, they plug in here. And that's just super thin plastic. It's about a 1/16 inch. You get it in different colors. It's really cheap at Canis Plastic. So
is that just to cover components that are just underneath that plastic?
Yeah, it's basically to keep kids' fingers out of the AC part. So put the power in, and then I'm going to have a connector or something that'll come out here that brings out my power.
Cool.
And then that's a bent wood box with a funny little, see those things? That whole face is zigzagged with the puzzle parts. That hold
it's a wraparound.
Yeah, so this is a single piece wraparound part that folds like that.
Oh.
So
wow.
It's
do you 3D print this? What is this?
No, that's machined on the CNC. So what I've done is I've cut, if you can see it there.
You're a smart guy, Doug.
I try sometimes.
That's cool.
I play a lot.
You should make a 2-pager or a PDF or something and just the gist of that idea, because that is a great idea. I love that.
Yeah.
You can thank the Haida for that. It's called a bent wood box. They did it in cedar, and that's how they store their oil in the winter, fish oil through the winter.
How
so they
old?
build it. Sorry?
When? How old were they doing this?
The Haida, 150 years ago.
I'm amazed they had 3D printers back then.
And they made it out of a wooden box, a single joint, and yeah, it's all. So there's only one joint, and they dowel that together, and that finished the box. They paint them with these beautiful patterns. But
how did you find out about that?
Can't you see the T-shirts I wear all the time? I love the friggin' Northwest
How
Coast
many
Haida
other
art.
crossover ideas do you have? So far in 10 minutes, you've talked about 2 really good ideas. One is using a PC board as the panel and even putting components on it. That's a good idea. And secondly is 3D printing basically Lego boxes that literally fold and interlock.
Yeah.
And you not 3D print, but you mill them so that even the key, like the tongue and groove part, is part of what you've done, and the joints.
Yep.
I mean, that's a pretty good idea.
Can you
I liked it. Thank you. I'm glad you appreciate it. I
That's
got a seal
brilliant.
of approval, and I'm on live streaming YouTube.
You you have your international debut on YouTube International.
And I try and keep such a low profile.
Yeah.
Yeah.
So as we expand Doug's head, we also have been doing another initiative in our group, which is to help people get going at Fusion. So we've got this Fusion challenge going, and so we just we just make up a challenge. Oh, can you make a disc? Can you make a die or a dice set or whatever? And I think the last week was lampshade. So does anybody have any show and tell or things that they'd like to share as with regard to this ongoing challenge?
I do.
Okay. Why don't you go ahead first then, Lakota?
Sure. Let me try to present my screen. Can you see it okay?
Yes. Yes.
Yeah. It looks like a crown.
Yeah, it is. Yeah, upside down it does. I tried to make it look a little like a spider web up top.
Yeah.
I was going to say it looks like a 3D spider web.
Yeah. Cool.
Cool.
Yeah, at first I was going to have
How
just
big
a
is
solid.
this physically, or have you actually built it?
I have not actually built it. I designed it. And
So what's
then,
the intended size, roughly?
let's see, I believe it's a foot tall. I think.
Okay.
I didn't
so
know
it's
exactly.
Roughly. So roughly, it's a foot by foot kind of thing.
Yeah. I
Okay.
didn't know how big to make an actual lampshade because I don't have one for reference. So
I am curious about something though. This doesn't look like it would shade the lamp unless maybe you put paper or translucent plastic around the gap in the center. What am I missing here?
yeah, I think you'd have to put paper on.
Like a shoji screen or something like that. Yeah.
Yeah, I'll just explain. Eric, I'll mention the challenge. We're not actually necessarily making anything, although with some of the challenges, people do make the item. This is just to sort of get people going in Fusion, and then we just do our little show and tell, and we try to, if someone got stuck, we help them with it.
Gotcha. Okay, now I understand. You know, the other thing this looks like, the bottom end of the Eiffel Tower. It occurs to me that could be your next Fusion challenge.
Cool.
That'd
That'd be fun.
Okay, it's not exactly the
Beautiful.
Eiffel Tower.
I like the
So-
shadow that it casts, though.
Look,
Thanks.
Lakota, I had a question. Those scalloped inner edges, what did you do to create those?
Oh, it was actually very simple. What I did, and I revised this a few times, but so if I were to do this again, I'd do it in a different order.
Yep.
But what I did was I created a sketch up here of a spider web, which is a little bit tricky to make.
Yep.
But yeah, I basically extruded it, and then
Oh, and then you put spheres, and where they intersect, it creates those lines. Yeah. Cool.
yeah,
That's
did a rev-
interesting.
I did a
That's
revolving
interesting.
cut to.
That's a great solution, actually.
So this tool is
Wow.
called Autodesk Fusion.
Fusion
Is this a
360.
free tool? Or are we using it in free mode?
Yeah.
It's free.
And is the idea that you can migrate design files from Fusion, for instance, to a CNC milling machine?
Yeah.
Yes, and a 3D
Or a 3D
printer
printer.
at the push of a
So
single
is
button.
that the design methodology, the tool flow, if you will, that you guys are thinking for a newbie like me might be suitable, or is that too complicated? Because I've
Well,
been
there's a
using
whole
Google
debate.
SketchUp up to this point.
We're not
Yeah,
there
I think
on
SketchUp's
that.
a good starting
Yeah.
point.
Okay.
Yeah. But on if you're doing
Yeah.
3D printing, you can go straight from Fusion to 3D printing because there's a really good post processor that just is almost seamless.
Okay. But there is not one for the CNC milling, or it's maybe
There
that's-
is, there is, but it's complex. It has so
Okay.
many bells and whistles. It's just a lot more complex.
Gotcha. Does anybody know if there's equivalent simple flow going from Google SketchUp to, for instance, CNC milling? Or what's the
The only
favorite
one is
tool
Yes.
for
Flatboys.
migrating those?
The Flatboys app, yeah.
Yeah, there is. It's called the Flatboys app. And we will cover that when we're talking about the small machines, when we get to the point where we've got a few machines built, or
Okay.
I think we'll get
Gotcha.
to that.
It does sound like this is my kind of group. Good call, Darcy.
Oh, yeah.
This is exactly what I needed. Kindergarten for idiots.
No, that's great.
So I guess beautiful, Lakota. I think it's nice.
Yeah.
Thank you.
I never thought of extruding from the bottom up like that to get a pattern. That's a really, really interesting concept.
Yeah.
Yeah, at first I was thinking of embossing a spider web design on, but I know you can do that in Inventor, but you can't use the emboss feature in Fusion. It's not there.
Mhm.
So I just decided to extrude it and then cut away a lamp shape out of it.
That's very cool.
So who's next?
I think Isabel said she had one too.
Okay.
If she's there, I don't know.
No, I didn't have a chance to.
Sorry,
make
sorry, I
something.
didn't mean to put pressure on you. I thought I thought I heard you pipe in. Sorry, my bad.
No problem.
Way to make people feel welcome, Doug.
I know. Well, Dave, do you have your rocket ship shaped? What's the very top of the rocket where the emergency escape vehicle? That could be your
Escape
lamp.
system?
Yeah, that could be your lampshade.
So for that one, when I drew it, I actually did it in FreeCAD, not in Fusion. And it's complex enough to design that I didn't draw it using any of the drawing tools. I wound up writing a Python script that calculated the vertexes and stuff like that. Because it is actually a very complex design. I looked at drawing it through manual processes, and it was just going to be horrific amounts of work. So I wound up actually writing some Python code to do that. You can do that in Fusion as well. I've not had need to do that particular one in Fusion, but yeah, maybe I'll give that a go this week and see how that looks, and I can show you guys how that's done. Because I have written some macros for Fusion. I've got one that generates nose cones, for example, which again I had in FreeCAD and ported over to Fusion, so that was pretty straightforward.
So isn't the nose cone, from what I've seen, like a convolution, like you just draw a Bezier and then rotate it like,
But the Beziers have specific shapes, and that's really where the macro came in. So you can have a simple cone, for example, or you can have a spherical, or the ogive, or there's a lot of different shapes, and they're optimized for different speeds and things like that. So there is a reasonable amount of theory. I didn't have to get into the theory. I just went to the Wikipedia page. It showed me all the formulas.
Okay, cool.
But again, getting that, if you had to draw that curve by hand, getting it into the precise shape would have been tedious at best, and just workable, really. So writing a macro made sense for that. But yeah, I just drew the profile and then revolved the profile.
Okay, neat.
So, do you have anything, Ray, or do you want me to do my lampshade?
Oh, I'm just loading the Fusion up. You can go first.
Okay. So I know we have new people here. So just to show you some of the prior challenges, the first one was a disc. And see, I made a disc.
Are you going to screen share?
What am I supposed to be looking at?
Oh, I gotta share. Thank you. I gotta actually click the button. It's not like only in my head that matters.
I don't want to know what's in your head, Darcy.
His special friend.
Yeah.
Yeah, so that was the first challenge. And then we did a dice. I eventually did this lovely one. And then we did a mug, and I did that. A gear was talked about, so I did that. And the lampshade is the one in question for today. And I think this is it. My secret project is a moon lampshade. But so here's my lampshade. I guess that's the latest one. This one looks 3D printable. So I'll just move the history back so you can see the steps here. So I started with, that. And I made this by sketching and then just revolving. And then once I did that, I then, let's see if we can see something that shows up here as I move through. Okay, shelled it to make it empty. And then I did an extrude. You can see I did this sketch right here. Or I'll have to double click that sketch. You see, I did a sketch, and this is based on a tutorial I found in YouTube. So I just sketched this on a plane that slices it. And then I'm going to extrude this thing out. And you can see in the next, if I finish the sketch, when I move to the next point, you can see that I've extruded it like that. And then I did a pattern of that. Is it called, what's this thing called here? A pattern. And I just rotated that thing around. And then looks like I shelled, then I shelled the top or the bottom here and kept going. And anyway, that's the deal. So looks like I made a hole at the bottom. Is that an extrude? Looks like I shelled the bottom to get that. So that's how I made mine. So I started by revolving to get a circular thing. And then using extrude, I made a pattern. And several YouTube videos demonstrate this technique.
So I have a question there, Darcy, and I've never used 360, but do you have control over where the light source is in the rendering?
I don't know how to do that yet, but
no.
Yeah, I don't know. You must have control over that. Well, one of the things is when you start your sketch, like if I did a new sketch here like this, plus when you start to do your drawing, you usually start with this button over here, and you pick a plane. So you know, even if you couldn't control the light, which I suspect you can, it's just a matter of how do you orient the item that you're doing.
Oh, I see.
And I made a pattern of just starting here, and I don't know if that's a good idea or not, just because I'm in SketchUp and before, and I just used to going to school and the teacher draws on the board an X and Y on the board. So
Right.
I want an X and I start drawing right here, you see? And then, you know, maybe you make a circle like that, and then I'll pick solid, extrude, and then I'll just extrude that into an object. And then, so now the light is, you know, so it looks like Z, you know, comes out.
Yep.
And it's the XZ plane is the floor, it looks like to me. So I don't know. I don't know the answer to that.
There is a way to do this because I've seen some really cool pictures come out of it, Dan. I think what we're looking at is the CAD part, but then there's another tool that you can pull up and it's under design, I think. The design button
render.
up there.
I'll be doing that a little
render.
later, Doug.
Okay, let Ray do it. Ray's way
I'll let
ahead.
Ray have the floor then.
Yeah.
Quick question. This Fusion 360, I was just checking on the web. It sort of says or it implies it's cloud-based. Do you actually run it on your machine or is it kind of running in a browser or something?
A bit of both.
It's kind of a hybrid.
If you're doing generating of forms, then it'll be in the cloud. But some of the more rudimentary stuff is on your computer. But some of the really heavy stuff, your computer won't handle it.
Oh, really? Huh.
Yeah.
Okay.
But you'll be a while before you get to the heavy stuff, presumably.
Well, I guess what I'm getting at is, do you actually download and install an app on your computer, or is it all running just inside a browser?
Yeah, there's an app.
There's an app. Yeah.
And it seems like it was saving to the cloud.
Yes.
You have a
Saves in the
cloud
cloud.
save? Yeah.
Yeah.
Is that the same?
And the local save, but the local save self-deletes in like
Yeah.
60 or 90 days or something.
I noticed you can export, they call it archive, and it saves a local file. But I bet that will be your own problem to manage in your own file system.
I don't trust Autodesk as far as I can throw them. Right there, I'm reluctant to invest time learning that tool. I just, you know, one of those things.
I agree with
We all
you,
have those
but they're
feelings.
offering so much.
Yeah, we all had those feelings, but I mean, you know, when you get into it, you can make some interesting things that we were finding challenging before. So I
Yeah.
can take all my files away and I'm still ahead.
Okay.
I think Darcy had one of the best arguments in favor. Like,
You can take the
I had a lot of
screen apart, right?
issues with losing the data because it's up in the cloud. The reality is 99% of what we do is a one-off. We're not in production, we're hobbyists. So we'll design something, we'll make it,
And it
And then
isn't
we're
high
done.
security stuff either.
and it's not security stuff. So, and you can save it all as exportable files if you really want to have it
But
locally.
you can grab it somehow and set it aside on your own hard
Yes.
drive.
Yeah.
Yes.
What was that about files automatically being deleted? Was that from your local machine or from the cloud?
From the local machine, yeah. So it doesn't fill up your computer.
It's just a cache for its own cloud business.
Oh,
Yeah.
okay. Okay. Okay.
You can save local files from here to eternity. What you don't have a guarantee is you can use their tools to open them, but you can
Got it.
export them as AutoCAD files or CATIA files or other formats. So you can always open them later. I think that you can even do SketchUp if you want, although I'm not sure that some of the stuff will export to it because
okay,
it's
I
too
understand
complex.
the model now. I get it. Yeah, it makes sense under those circumstances. I guess it's okay as long as it's free. It's free.
Yeah.
And we're enjoying the ride for now.
Oh yeah.
Yeah.
Okay, Ray, demo time.
All right. Okay, can you see that?
Yeah.
Yep.
So what I did is I made my lampshade out of glass.
Okay.
And so that's a little different. This is in the render.
Yeah.
So this is what Doug was trying to explain. So you can see the little brass parts up there. So in theory, this is makeable, but in reality, maybe not. So this
Is this supposed to be a lampshade shaped like a potato? Like what's the shape that I should recognize?
You sort of went with an organic blown glass shape.
Okay.
And I used a different set of features than most people use. So instead of walking you through this, I'm just going to start with a new design. And I'll show you what I did. So I used a different mode. I used the create mode. So I clicked here and I picked cylinder and I picked a plane. So what I have is so there's basically the idea of the lampshade is right there already. So I can adjust this width-wise. I can adjust this height-wise. And if you see this little thing here, I can adjust how many segments it has, which is kind of important. And I can adjust the segments this way as well. Because every segment, every intersection, and every line is manipulatable.
Right.
So,
and then you started twerking all the intersections to get whatever bizarre shape you want. It splines the rest, does it?
Right. So this is actually just right-click, edit form. I pick something, and I just pull on it a little.
Gotcha.
Or I pick a whole plane, and I push on it a little. So I end up with like a blown glass shape, very easy to do. Or I pick a line and I pull on it a little. And there's a lot of modifies, like crease. If I put crease on this one, and then I edit the form.
This feature should be called "How to Make Something Brand New Look Dented and Old."
Yeah, this could be a pop can, that's been around for a while. But see, when I put the crease modifier on it versus this one, it's quite sharper. So there's a lot of different modifications that I could do. Then I did the offset plane again. Offset plane, brought it up. Did my sketch here with the 3 bars and the hole in the middle. If you want me to go through that, I will, but I think that's been covered in some of the other ones. So this is a feature that people don't usually use. And when I go over here to design, I can go to render. And I can, well, actually, let's go back to design. So I can go into modify and go to appearance. Come on, here we go. And one of the appearances is glass. And for example, I could just give it glass. Use that. So that's presumably that's supposed to be glass, but anyway, that's better looking glass. So that's all I did, is I just modified it so it looked like a big blown glass lampshade. Now the interesting part about, I'm going to start a new design again. The interesting part about this is you want a box for something, You could just take like a box. You're making a box for whatever device that you have inside. Okay. Something's happened. Try that again.
Well, gentlemen, I got to go in a minute. It's been very interesting. I will follow with interest your future Zoom meetings. And in the meantime, I guess I better download Fusion 360 and give it a whirl. But thank you for sharing a meeting with me. And Darcy, thanks for the invite.
See you next time.
See ya.
See ya.
So in create mode, so you end up with a blob, like when you pick, but you can make it almost a box by increasing the number of segments.
Mm-hmm.
But I mean, if you really wanted a box, then you'd probably stay in the regular design mode. But you can get organic shapes. If you make something and you want a shape that fits around something, a shell, then this might be the way to go. And again, you can modify this. Oh, come on.
Oh, wow.
It's a stick shift.
An anvil.
An anvil.
Yeah, or an anvil. Yeah.
But then you can finish form. And what this does is it creates a body and you're back into the design. So you can do your normal stuff like just create a sketch. Say center circle. So now you've got this hole through it. So it's just another body that you've created a very organic shape. And so you can create a box, or if you use the shell command, where is that? Here. I'll pick the hole itself. And now it's hollow. So that could be like a box for a piece of electronics or whatever. You could 3D print that and it would fit around. Very slick. It has a great presentation overall. You put the holes where you want it for the knobs or whatever. And I think that's printable and you could do it in sections. So that's just, I thought there was an interesting feature to bring forward.
Yeah, for sure.
Yeah.
Awesome.
What about more complicated things? Like, could you put threads into that hole?
Yes.
Ray, where'd you
use
specify
hole
the
for that.
thickness of the object?
In shell, modify, where is it here? Oh.
Up.
Up. Yeah,
There.
it's the first one. That's why I didn't see it. So I pick a, okay, let's.
And it's just asking you to type in a number there. Oop.
Okay.
I have to drop off. I will hopefully get back before you guys are done your other discussion, but if not,
Okay.
take care. We'll catch
Okay.
you soon.
Yeah.
Bye.
Take
Hi,
care.
Ned.
Bye-bye.
Yeah, okay. Modify shell command off of this end. Okay, see, as soon as I click on the surface, I have that little dialogue. So if I
Okay,
hit
yeah, okay,
2
right.
millimeters, it'd be 2 millimeters.
Okay. Okay, wow.
5 millimeters, it would be 5 millimeters. So really, really quick. And I can pick like I can pick more than one surface, and so then you can have multiple holes going in. So it's a slick little a trick. And someone asked about threads. There is a thread thing. Let's see.
Also, when you do hole, you can do thread too.
Oh yeah, there it is, thread.
Oh, okay. Yep.
So you click on thread, you click on the edge. Whoops.
And would those threads be 3D printable?
You can there's two different ways to do it. You can just have a decal on it showing a thread, which is good for some applications, or you can actually have the 3D printable thread, the actual thread in the design. So there's two.
Yeah, there are some good YouTube videos out there for creating 3D printed threaded parts.
Because I was thinking as well that if you dimensioned it correctly, you could just maybe clean it up with a real tap afterwards to get better quality threads without having to remove so much material.
Threads like that, you're probably going to be disappointed because 3D printers don't have the resolution. In that
case, it's really up to
you're just going to cut a hole and then use an actual tap.
Yeah, exactly.
Yeah.
But at least it would be close, and you wouldn't have to be, removing so much material, or if it's in a difficult place, maybe to be able to tap it.
Yeah, another common thing for threads with 3D printing is you can get brass inserts, and you use a soldering iron to put them in because it heats the plastic just enough. But that gives you a brass piece that's going to hold your thread, so it's level.
And I guess they're reinforced on the outer edge so that it has a good physical grip to the plastic.
Yeah, I use that on my rockets all the time because I have the electronic sleds that hold the electronics to control the rocket. And for those, I use the brass inserts because I don't want those things flying around.
It's surprising though. Oh, sorry. But the 3D printed threads, like they do work they work better than I would have
Yeah,
thought.
it depends on your application.
Yeah.
Yeah.
I got some right here. See, I made this thing just yesterday, and you can unscrew this piece, you see. So it's really sloppy, but for this application, it's fine.
Right.
But yeah, you can print out the threads for any standard thread, or you can make your own very custom thread using like the spiral tool and using it as a cut and putting in whatever angles, and then you can make a proprietary thread that's going to annoy everybody, but you can have it. The machine is capable of doing that. And there's some good YouTube videos on how to make threads, the crazy proprietorial ones, or just import, stuff from McMaster and just pop it in.
That's very cool.
Yeah.
Yeah, if you're interested in seeing quickly another example that uses the same tool that Ray was showing, I can, since it seems to be something that's a little bit new, I can show you. It's not a lamp, but it's something very similar.
Yeah, if you're really interested in learning how to use the Create tool, there's a YouTube video on how to make a Pikachu. And I thought that covered a lot of things, and then you end up with your very own Pikachu. So that's the one I would recommend.
Thanks, Ray.
This one that I'm showing, I had to make a topographic
Yeah, that's
topographic, yeah.
Topographic map. And I use the same tool. So I work in science outreach and science education. So we were making a science kit for high school about climate change and measuring the ice thickness. So we wanted to simulate like the surface of a lake or something like that, with a layer of water and then a layer of ice on top, and how you would like extract a cylinder and how you would measure the ice thickness.
Yep.
Yeah, so it's the same tool that was just shown. So I started with a grid like that, and then I pulled up some parts to make like different thicknesses. I made this a while ago, so I won't remember like all the detail necessarily. Then I did another one. Whoops. Spoiler alert. Yeah, so I made another one on top. So I'll visualize it like that. So that then when you had like, let me show after. Then a couple extrudes after. So you can see the bottom was supposed to be like I printed out blue to the water, and then the top part was white. So, you know, the kids couldn't guess. Like here, it looks like it's very thick, but maybe like the blue part is very thick and the white part isn't as thick. And then I started to work with more the standard tools that we know. So I made like little pegs sticking out and a cylinder that cut into it. Yeah, so I ended up with these. Let me turn off a few bodies here. So you can see I had like these little bodies. So yeah, I kind of forgot what I named what, but you get the idea. And I numbered them. So let me turn back everything. So at the end, you ended up with like these 9 little like cylinders that you could pull out, and you could see the different layers inside of different colors. And they were supposed to find like what's the safest path across the ice based on those cylinders that they pulled out. But for me, that was really the project where I learned a bit about that different environment that Ray was showing, because you needed that organic shape.
So, and you actually printed these?
Yeah, hundreds.
How long did that take? Because you're using different colors too, right?
Yeah, so we kind of, so like there's 2 offices that work for the same organization that have also a 3D printer. So usually I design it and then we distribute it across the offices, and different people like print different parts. But it must have take like, I would say 3 weeks.
Wow.
Yeah. Yeah. But you know, it's really nice for some of the kids that we do in schools like that, be able to just, like, the original idea that was proposed by the group we were working with was to do this with like a bowl with like water in it, and then you put shaving cream on top, and then you take a sample, which is, it sounds good idea, but just thinking about the practicality of it, we could just see how much a mess it's going to be. So it's really nice. Like we've really, with 3D printing, been able to do a lot of like custom educational kind of stuff like that. Yeah. Anyways, that was just another quick example to show the relevance of the tool that was just shown.
Very nice.
Oh, that's awesome.
Isabel, what grade was this?
We did it for grade 10 to 12.
Oh, okay, high school.
Oh, wow.
Yeah,
Okay.
yeah, yeah. But in general, it's like from preschool to end of high school. So it just depends on the topic.
Beauty. Any other show and tell or calls for support or help? I'll take that as no for now. Feel free to interrupt if something comes up soon.
So
any objections?
Greg was asking about earlier
Greg,
before he asked if I could show how to draw is this piece. So as you can see, it slopes in on both sides, which was the first bit. Plus there's a central ring with all those struts connecting it. So that's why I did that using a program instead of trying to draw it by hand. It's actually a pretty complex shape. I have the macros online if anyone wants to have a look at it. But
so the purpose of that ring in the middle is to strengthen the entire structure. I mean,
so this is the part of the Saturn V and the Saturn 1B rockets.
Yeah.
And what would happen is there's a very heavy rocket motor on the top part here. So I imagine what the purpose of the rings are, and I don't know this for sure, is for torsion.
Okay.
So if it starts twisting, obviously that's a lot of weight, but yeah, it's a pretty clever design. Even 3D printed, this thing is strong.
Sorry, I'm curious, Dave, what was this in the set? It looks like some kind of escape tower or something like that.
Yeah, yeah. So this is a fiberglass cover called the boost protective cover. The launch escape tower, and then there's the launch escape system here. So basically you had a tower with multiple rocket motors. In the best case, it just literally picked the cover off and shifted it to the side so that the rocket could carry on its way. But there was also a bigger motor in the event of an emergency that would take the whole capsule and lift it off the rocket and shift it to the side in case it was about to explode, for example.
Right.
So they have similar things for like the Dragon capsule. That was one of the big tests they did. The worst case scenario is right at maximum atmospheric pressure. So where the atmosphere is still thick and you're going fast enough that you get the maximum pressure. So that's where they did their test of it. And it lifted the capsule to the side, and then the booster just basically exploded under its own aerodynamic forces and all that. It just compressed the booster. Things went boom, but the capsule was far away. So yeah.
Yeah, the engineering on those struts is interesting.
Oh, it's absolutely astounding. So there are a couple of minor features on here, one of which is, so I don't have it on here because it's small and would have been hard to draw. There's steps going up here so that someone can actually climb this thing. And you got to remember, on a Saturn V, this is 350 feet in the air. Yeah, I'm not climbing that. Yeah, but there's some nice images of that thing out there. It's really, I mean, just looking at the structure of that thing, it's so simple and yet such a beautiful design and how it's going to balance those forces. It's really astounding. So
Dave, are those actually, is that whole thing covered with some kind of shroud? Why you, like, I've never seen anything like that before. Anything to do with the moon launches and stuff like that.
Yeah, so this was all the moon launch. Basically this is a fiberglass shell. You can see it's built in segments, and it literally lifts itself off the rocket once it reaches high enough, and the rocket.
The point I'm making though is that very elaborate little tower you've done there. I've never seen that before.
Yeah, you have. You just haven't realized it. Hang on, I'll send you some images. Can we post an image on here? Well, actually, I can share an image. Hang on.
Put it in chat, or you can share your screen.
Yeah, I'll share my screen. Give me a sec here. Let me find it first. I think I'm close. It is. There we go. Boom, boom. That's a good image of it. Sorry, I'm trying to think about three things at once here. There we go. Oh, there it is.
Oh, top of the pad. Okay. Oh.
So you can see that this is actually a fiberglass cover for the thing. It's not the capsule itself. The capsule is just aluminum, right? So it's got that color for it. Okay. Are you seeing this image of the Apollo capsule? Or do I have to show that separately? Okay, so you can see that this is the part that it covers. It's just an aluminum cover. It's very rough in shape, but it covers the features of the capsule itself. Yeah, so in the event of an abort, it literally picks up the command module, so it leaves everything from the service module down in place and just kind of lifts and shifts. But yeah, that's a very beautiful design for a tower. I don't know if I have any images of the tower close up. I've come across them, but I don't think I have them here. Yeah, no.
Boy, the forces on that must be just incredible.
Yeah, it must be a lot of vibration and coming off of that.
Well, that's the thing. You do have to handle all the vibration and things like that. So like I said, it's a very simple design, but it's just, you know, so beautifully designed. And
it's kind of like the complexity of a bridge truss system where you've got lots of forces that shift over. But yeah, I mean, at the same time, this is moving and rotating and moving in multiple axes at the same time, which bridges don't have to deal with.
Most of the stress obviously is going to be straight down, but yeah, there's obviously going to be at least some minor torsional forces on that. So you can see we have the triangular struts here, but this ring structure, I mean, that's just.
Well, when it moves to the side, is there not aerodynamic loading that comes at not a perfect straight up and down? I mean, if it's moving to the side, are you not getting some
yeah, you'll probably get some lateral forces, but remember, even when it's moving to the side, it's pointing to the side, so it's still pointing.
Oh, I see. Yeah. Yeah.
So yeah. But yeah, that's a lot of pressure on that. So it actually isn't going fast at maximum aerodynamic pressure. It's only like Mach 2 or below. And what you'll find is a lot of the rockets throttle down until they get through that transition. And they call it max Q. So if you watch SpaceX flights, they mention that point. And at that point, then they put the motors up to full power again and they start thrusting through the thinner air.
But they're already over Mach 1, so there must be a shock wave there.
Yeah, there is.
Where would that shock wave intersect that structure?
That's a very good. Well, it probably wouldn't intersect the structure because, I mean, you've got this skirt here. So
right.
The shock wave is going to be kind of going out like that.
I see.
I'm sure there's some that goes in around, but I mean.
So they're trying to push the shock wave around the rest of the capsule so that it's.
Yeah, I don't know if it goes fully around
the
capsule or not, but it certainly would go around the tower. It wouldn't be too bad on the tower itself. Now, you might get a negative pressure on the tower, but so again, I mean, this might have some actual pulling forces because of that.
Right.
Yeah.
Interesting.
Yeah, it's fun stuff.
Yeah.
You know what? I'm always amazed at the Saturn project. You know, they did all this massive engineering, and in the computers and all that kind of stuff were just terrible by today's standards.
Well,
you know,
one of the things I had to worry about when I was building my level 3 qualifier was something called flutter. And that's where basically, if you get a sideways pressure on a fin, for example, it's going to have some flex. And if you're going fast enough, that flex gets to the point where it disintegrates.
So you get metal fatigue building up very quickly. And,
yeah, exactly.
Yeah.
So, and actually the 747 had that problem, the original prototypes, when it got close to top speed, and they had to put some damping in to correct that. But so I did that analysis for my level 3 rocket, and I was actually pretty borderline. I had to reinforce that with carbon fiber and all that kind of stuff. When I did the Saturn 1B model, I did a similar analysis, and it wasn't even close. I had so much margin. It was, I mean, it turns out NASA scientists actually knew what they were doing.
Yeah.
And again, all this before computers. It was done with slide rules, and you know, it was,
yeah, there was no big simulations and model, you know, 3D, you know, modeling and all that kind of stuff didn't exist yet, right? So
yeah,
I bet they did use wind tunnels and so they had some real.
So I mean, a lot of the theory was in place. I mean, they knew about finite element analysis and things like that, and there was some stuff being done, but it was, you know, it's stuff you could run on your cell phone today easily. It wasn't complex stuff, right?
Yeah.
So a simple structure like this, they could have done a finite element model of, because it's just a single vector for each of the struts. And again, just brilliant design. So.
Yeah.
When I was in graduate school, and this is about 1970, one of my university profs went down to Houston. He came back, he said there was a massive analog computer that actually, if you don't know analog computers, they look like just giant patch boards.
Yeah.
And this thing was huge and had like a couple of thousand patches. And it was over top with simulation of moon landing. Do not touch.
Yeah. Yeah, those things were like Enigma to accept in the backwards process. You had to be smart enough to figure out Enigma in order to program those things in the first place.
Yes. I had brief contact with those in graduate school, and the trick was to do the scaling to make it so that you didn't all your variables were going to be voltages, and of course the voltages had a limit to how high they could go. So you had to scale the problem down so that you didn't overdrive one of the outputs.
Yeah, I'm certainly old enough to have had some early exposure in my career to analog computing, but it was more on the, hey, this is the way we used to do it, and this is why we don't do it anymore.
Yeah, exactly, yes.
So let's make sure we're done on the fusion. So I know Duncan is pretty new, and I think he started to work on the challenges. So do you have anything to share, Duncan, where you're at with that, in case this is a chance that we can give you a hand if you need it?
I didn't get into any of the challenges, but I got my foot in the door. I was looking up a YouTube video where the guy was building like a conduit box. And I started working through that, but that was just last night.
Okay.
So I sort of like built a box and then like was able to like round the edges and extrude it.
Good.
Oh yeah, that's Larry,
right. To the side.
Yeah, he's actually pretty good. Follow his channel if you're looking at getting into fusion, because he has some Q&A sessions as well. And I've actually asked questions on Twitter, and he's responded pretty quickly. He's really quite helpful.
Yeah, that exact video you're mentioning, I think is the first video I watched, and it really set me on my way. Like after following all the steps that he did with the conduit box, I was able to start experimenting with my own stuff in Fusion.
And now you can wire your own house.
I guess I'm starting in the right place then.
Yes, you definitely are.
Yeah.
There's one thing that confused me a couple of times is somehow I'd had the wrong thing selected and was having trouble going from the sketch mode into the 3D mode where I could extrude.
Well, that gets into the problem Isabel mentioned last week, because the user interface has changed a lot since he made those videos. So you are unfortunately going to encounter some of that where what he's talking about is in there, but it's not in the same place.
Right. And the one that I watched before that would be Learn Fusion 360 or Die Trying. So that's even more primary. And I found that one's what got me boosted to go into the one that you just did. So I found that to be very good. Really cleared up a lot of little problems.
Anything else in the Fusion stuff? Just to, just wanted to make sure that nobody gets left, because pretty soon I'm going to try and start the discussion about the CNC purchase. We're not on a strict schedule of any kind, and there's time if anybody wants to talk about anything else. I just wanted to make sure we didn't miss anybody.
I guess looking at some of the basics in that other video might help, because there's a couple of spots where like I screwed something up and the only thing I couldn't figure it out, and I just went back and started again because it didn't take very long at that point.
Right.
It's just a few little things like that to be able to navigate through a couple of mistakes that help, but I'll look at that video.
Yeah, get used to that. It's going to happen when you're starting, even after you've been at it for a while. That stuff just happens.
So we could start whenever you guys are ready for the CNC discussion about this big group purchase that we've been talking about.
Are you excited about CNCs, Darcy?
Oh, I always am. Because even though I got CNCs coming out of my ears, but I like it a lot, and I find the more our community builds up around it, the more fun I have with it, because we just keep on figuring out new stuff to do, with these machines. But yeah, if there's nothing else, I'll get that going, even though we're a couple minutes ahead of schedule. So this whole idea, I thought of bringing this concept of doing a group purchase, because a lot of people are intimidated by getting a CNC, because first they cost a lot of money, and then after that, what are you going to do with it? How do you do it? What can you do? All that stuff's really a big project. And now these newer machines, which are they call them CNC 3018. That's what they're called. They're really, really affordable. And I thought, well, anyone can really get into CNC with these things. And they're pretty cute little machines for the dollar. And I thought, well, if a few people could build it, have a lot of fun, learn everything you need to know about CNC. And then later, you could just buy a big machine for whatever purpose if you needed a bigger machine. Rather than have to delve right in and spend thousands and thousands of dollars, why not start with a $200 project that actually has a lot of, useful stuff. Now, I'll show you what the machines look like. I got one right here. I'll just bring it over to the camera. So this is what they look like right here, and I better turn off my background because you won't be able to see the thing. So I'll just come here and put on a different background. Oops, virtual background. And let's try and pick a background. Oops, that was my flat earth background. Don't want that one. There we go. So this is what they look like. I'll just tilt this down here. They're just this little tiny machine. So this is small enough you could walk around with this thing holding it with one hand like that. So they don't weigh very much. They're really easy to bring wherever you want. And so, and the cutting area, that's why they're called a 3018. So this has like a work surface right here that I can work on. And that term 3018 means this thing can cut 30 centimeters on this axis and 18 centimeters on that axis. Okay, so I'm gonna share my screen now so that you can see this on it, sort of a picture, and share a screen there. So I'll just put this aside for a minute and sort of compare a couple things so you can see. So like I'm just making this as a broad recommendation that it's an affordable machine that anyone could start with. And so I just go into my printmaking here, and I just did this project the other day for fun with this in mind. I made a thank you card here, and I was showing it during our social earlier. But in the design file, and I used Inkscape, as you can see here. And it's just popping up, I think. Did I double click it? Yeah, I guess I did. So this is a nice, good sized desktop machine. It's called a 6040. And that whole box that I just selected is a 6040 size machine. And I've got one of those machines, and I'll show that in a minute. Or actually, no, I'll show it right now. If I go here, and I'm going to go over, and this is a 6040 right here. See that thing there in my other camera. So that's about there's one more size after this that you can fit on your desktop, and it's called a 6090. And of course, that's almost a meter of a cutting area. And now here's where the rub comes in. It's that a good 6090 is about $5,000. You can get a low end one, you know, for say 3,000 or something like that. And no one wants to play with that money, and that takes up your whole, it's a massive machine. You can't pick it up by yourself. Even this 6040 I have, I wouldn't pick it up myself. I wouldn't even try. I've done that before. I did it a few years ago, and I'm still paying for that. So anyway, so that's a 6040. I feel they're a good buy. That 6040 I just showed, I only paid like $1,000 for that thing. Maybe it was 1,200 with the conversion and the taxes and the shipping, but something like that, $1,200 or $1,300. And that's a pretty strong value proposition. If you've got space and you're sure you want it, that's pretty cool. But what about people who don't need such a big machine, or you don't really want to invest this much yet? Much of the benefit can be had on these 3018. And there's the 3018 size we're talking about right now. Okay, if you put it, so it's like 4 times, it's like a quarter of a 6040, right. You know? And so that gives you, so that's the work area we're talking about. Now, the reason this machine is so nice and light is because the smaller you make it, the lighter it can be. And it goes up exponentially, like, or with the cube, I guess. Because when you imagine, if you make the machine longer, then the members start to eventually bend under stress. So you've got to make them bigger, but not proportionally bigger to the size you're making it. This thing gets heavy. Like this 3018, I can walk around. I can carry 2 of them, you know, just in one hand by putting them together, grabbing the 2 beams and walking around with it, no problem. By the time you get to a 6040, you need 2 people minimum, and a 6090, you need 3 people to lift it, because you're really working when you're lifting these things. So, you know, there's just, this size is just such a nice size that it becomes portable. And other common sizes. So 3020 is another size, and it's oddly, those machines are usually made very heavy. And I had one that weighed about 60 pounds. I don't know what my 3018 weighs, but it sure doesn't weigh that much. And it's plenty rigid. Like, I think you could do aluminum on this thing, plenty hardwood or anything like that, as long as you're not too greedy about how fast you want to get things done. Another common size is 3040. They're also a good buy. I think the 6040 and the 3040 are two. The 3040 is about the biggest you can lift up by yourself. See, that's just designed for one person to carry. And then, so anyway, that's sort of the size we're talking about, and that's a limitation of this machine. At 3018, you're going to be limited to what you can get into that machine and cut. And that's just one of the payoffs. So if you want to go bigger, the weight and the price just goes up with the cube of the size, basically. And
what's an example of some of what you'd need for those sizes? Like, I mean, you know, on the 3018, could you not just take your project and build it as smaller parts that end up
absolutely,
getting...
just make it in parts.
Right.
Yeah,
so
like one of the
where would you have to have a 60/40 in order to be able to do it at, you know, where you couldn't do that? I mean, what are you missing out on by only having a 3018?
You can make a big part in one shot with the 60/40. Even when you're making smaller parts, just having the big bed to work on sometimes can be really handy too. I even use it to put tools on. I mean, I shouldn't, but so yeah, it's that's really it. It's a lifestyle. Here's another one though. When you buy the material, like I just made an order at KJP, and I got these lovely boards, and they come in, and I was able to order them 12 inches wide or 18. I got some 12s and some of them are 16 inches. They just fit right on the 60/40. So I can take the material right in from KJP, and it goes right on the machine. And then I just keep cutting until that piece is done. It might take me a week to work through a piece, you know, and just making whatever parts that I need. Now on the smaller machine, you're going to have to get you need yourself a jigsaw to get the pieces broken down to put on it, and you know, and all that. So I just did a fun.
Actually, Darcy, before you go on, I want to follow this thought through a little. So for example, when I was building my Saturn 1B, I had centering rings that were about 30 centimeters across. So with the 3018, I'd have to do half of it, turn it around, and then mill the other half. How easy is it to get it lined up correctly, or is that
is up to you on what kind of fixturing and, you know, precautions, measures, and techniques and tactics. That would come from practice. If you're really serious, like I think the 3018 is a good deal, and it's almost like a no-brainer. Anyone can get into this game. Let's take the worst outcome. You buy yourself a 3018, you pay $200 to $300 or whatever, and then, oh my God, I don't like CNC. You put the thing on the market in our community, you probably get most of your money back for the thing. So you're not really exposing yourself.
Especially if you have it assembled already.
Yeah, it's like, hey, I'll take it. Yeah, so I think that at this rate, not to judge for people's own economics, but at these price points, when you're talking like in just a couple $100, $300 to get a whole kit or something like that together, I think that you're not exposing yourself to too much risk. It's not like going out and buying a 6090, you know, a nice one. You can buy a nice 6090 for like 10 grand. You can get yourself a beautiful one. But I mean, you're really getting into some heavy change there and space requirements. Whereas this
3040s, I'm looking at the prices here. You're looking at around 600 for those.
Exactly. And those are heavier built machines too. Like I noticed that like for each size, there's a general way that they're usually constructed. Mostly, there's exceptions, and it seems like the 3018 and down, they're made out of this extruded aluminum stuff that we're seeing here, and then. And above that threshold, as soon as you get to 3020, they start making them out of much beefier materials. And it's probably to do with the geometry and how much flex is usually allowed and the price points of all the different sizes of the materials. But I just made this project, which I found really inspiring, to make this lovely thank you card. And I even made the fixture. You can see that helps me align the prints because I'm using, you can see here I'm printing the blue area, and then I print the hair as a separate. And here's my jig for doing that right here. Here it is, you see? And I actually got it. Yeah, so I actually made it, and here it is. And so what I do is to print with this, and this is just a printmaking project. Not everybody will like printmaking, but I know a couple of us are a bit interested in it. So I made this frame. You can tell I had a problem when I was cutting it. But at least I got the center part right before it screwed up on the outside, and I don't care. So you put your card stock in here to make your little nice thank you card, and then you put the frame on it like this, okay? And now when you ink up this block, which I carved, and you put that on there, and then you can either jump around on it for a while or put it to a press or whatever you like, and you take it off. And then to get the hair in place, you just flip this over like this. See, and it fits this perfectly. There's no gaps or anything. It's a very satisfying thing. You ink up the hair and you stick it in the hole. And then it's so small, you just press with your finger and you get enough force to transfer the ink. And basically, so this whole thing, I was able to make it, I could make that on a 3018, no problem. you know. So if you wanted something bigger than this, well, you could just put it, you could just see how it fits up on the screen here. Yeah, I'm on the share here. Yeah, if you look, you see there's your 3018 and here's my project right here. You see? So, you know, if the project was much bigger, it would be rather inconvenient. Might, you know, go to a bigger machine. Like if you wanted to make a big, even though I could make a 30 by 18 print, if I want to make the fixture, I got to make it in parts. And that'll just be another hour of thinking about how to do it. So it's like a lifestyle choice. Now, my angle is, if you're serious and you're gonna have fun with some CNC, I have a bunch of CNCs. So so the thing is, you can have one machine busy, you can go on the next one. And I've got these little 3018s are portable. I can bring them to meetups, and then next summer I'll be bringing them to the park. We'll be doing picnics. Like I literally have a Honda generator. You can actually see it on my screen down there, I think, that red thing down there. Oh no, that's garbage. Yeah, but it's just a little further over, there's a Honda generator. Anyway, so that's sort of part of my thinking here of why I think this is a particularly good opportunity to get a CNC machine. Because even if it's too small in the long haul, well, by the time you use this thing for a while, you'll know what you want more. You'll be making stuff and you figure out, do I really need something bigger? Do I not? Do I need a heavier machine for doing aluminum? You'll be able to answer those questions and you'll know what you need. And in the end game, I love having a 3018, even though I've got all kinds of other heavier, stronger machines. It's just, to me, I see it as low risk. That's why I was going to advocate for this. Now, where to buy these? That's the next thing. So I'm just going to bring me up a web browser here. Now, everyone has their own style. And 3 good ways that I know of, and you can tell me if you've got other ways: eBay, and then there's Amazon, and then there's what's that other one there? That's
AliExpress.
Yeah, AliExpress. AliExpress is a good one. Now, I bought my 3018 in eBay, and so if I go CNC, say 3018, 6040, whatever you want. And now this class of machine, like that I call 3018, they make smaller ones. They're like 12, 18, I don't know. And they're like little smaller, and they're the same machine, but just chopped. Like they just chopped all the parts and they're giving you less material. So they're charging less. And I think you could get a smaller one. I got a buddy, he got a smaller one. He only cuts pucks with it. So he just chopped one of these things down to nothing. But you can see here and this is another aspect of yourself, you know, how much risk is there in the purchase mechanism. Like if I look at, say, this random one, it's all anodized and looks nice. This is exactly the one I have, by the way. So that's $182 US. And if I go open that up, we can have an eyeball here. And you can see that comes with free shipping. So this is probably a good deal. The buyer's got a little bit of a low rating. So if the thing is junk, you're going to be in probably not have as high of a chance of getting satisfaction. But the thing is, they're probably all the same. And so there's your eBay option. And I noticed in Amazon, you get same thing, CNC. I notice it's more expensive generally lately. I don't know if that's a pandemic thing or whatever. And you can see there they all are. There's some variety in them. Like you'll notice that some of them have like this frame like that, and then some of them have a lighter extruded aluminum. This is the one I have. And this is, when you hear the term pro, that means it's not this cheaper one that I have. It's this other one. And with the cheap one, I don't know if it's cheap or not, but you have to add this extra hardware to attach all of the rails, whereas with the pro one, it's all pre-drilled. So apparently the assembly is a little easier to put together. And I noticed when I did the AliExpress, I got something very pleasant. CNC 3018. I did this. I saw 2 really pleasant things here when I did this. One of them was I saw, it might have been this one, that one. And then I saw this other really beautiful one right here. Okay, so this one, yeah, this is the one. And they got it as color. And so you go, so there it is, 172. And you pick the first one, and those are your options, you see. And this, and you click this one, you get different sets of options with it. See, you got a goggle, you got, so some of these machines come with a laser that you can snap onto the thing, and you can do laser engraving or whatever. I'm kind of afraid of the laser myself. And maybe this isn't the one that I actually saw, because the one I saw was really affordable, and that's what drew my mind. Maybe it's this one or something. I saw one here that maybe it's this one then. It was just really affordable, and it showed all the options that you can get. Yeah, they all have lots of options. Okay, that's so. I noticed with this, you get options. I don't find that as often in the eBay sellers, but the one that I'm advocating is the cheapest one that you can get. But there's one thing to look out for. It's the chuck. Okay, now the one you want is ER11. A lot of these cheaper ones don't have this ER11 chuck on there, and you want an ER11 chuck because it's a very convenient chuck. And the other alternative that it'll probably be hard to find one right away. I'll see if I can find one in a picture at least. Some of them are photographing whether the chuck installed, so that for one reason or the other. But the ones that don't come with it, now all these pictures have it by the looks of it, either they're not showing. The ones that don't have it, they come with just a little collar, not a proper chuck with a collet, but just a collar. And I'm pretty sure those things are going to wiggle, and we call that run out in CNC machines. If it wiggles, if it's not axial, if it can jiggle or wiggle, we call that run out, and you really don't want run out on these machines. Another weakness of this class of machine is these little motors aren't very strong. Okay, we don't know how long they last either. They have bushings instead of ball bearings, but they're pretty easy. I already even have a spare one in stock already, and I think they're called, well, I guess you have to click one of these to find out what those motors are called. It's probably listed in here what motor it is. Where is it? Oh, it's called a 775. So if you go looking for those, you just do 775 motor. You can buy those things. And, so when if you cook your motor, you're in for, $10, $15 type of a problem, or here's one, $8.50 US. We'll see if they've got, 8 and 8. So yeah, $15 to get a motor, if you blew up your motor.
That's the spindle motor, right? That's that does the cutting, not the steppers that are.
Absolutely, yeah. The steppers are your traditional NEMA 17s that you're going to find on any 3D printer, and this is like a 3D printing technology applied to CNC. It's like NEMA 17 with little Pululu style drivers in there to drive all the little steppers. And the stepper, they come with a little controller board and everything. Like if I click this one here, and you'll usually see a picture of the controller board. I'm not seeing it, but we'll see if it pops up here. Yeah, they all kind of have every different one. I find there's little different versions of the board, and I say just get the cheapest. There's another option out there that you can run it headless. So you put an SD card in like a 3D printer. Okay. I got that option, and I don't find it very interesting. And you can buy that option later as well. So I say buy the very minimum and get, as long as you got an ER11, I think you're good to go. Anyway, so
what about the connections to the to hold the work down? Is there a variation?
Yeah, a hold down kit. So you see this one comes with some parts here for hold down. They're calling it, I don't know, whatever that is. Yeah, I find almost they all come with that. And this, you could meet, your worst case scenario is you'll head down to Ottawa Fastener to get some stuff for that. And they're using this extruded aluminum channel here, and you can put a bolt into one of those grooves and it will capture at the bottom. So yeah, so you just basically, some people are 3D printing hold down kits for that. I use on my main 6040, not this 6040 here, but on my main one, I actually use clamps. They're just ordinary clamp on, you pull the trigger to undo them. And the ledge of the machine comes over the front of the table, and I just literally clamp to the machine. And it's instant. You just throw your board on, you clamp it, and I put a ballast at the back side of it, and I just do my cutting.
But that's with an overhead gantry, though.
Yeah, exactly.
So that's a different method than you would use on this.
Yeah, here, yeah, you wouldn't use that on this particular machine unless you could find a clamp that would clamp onto this. This is a moving table machine.
Right. So the table moves instead of the gantries going back and forth.
So you won't
Correct.
be clamping like that.
It's a stationary gantry, basically.
For some things, could you not slide in something that acts like just like a little mini vise on there to hold the work to that?
Yeah.
You can buy them actually.
Oh yeah, absolutely. I should mention one feature of this machine is there's not much room. Like if you look at the tip there, and he's only got about another centimeter to go up there. And well, let's see if I can zoom this guy. I can't zoom this one, but maybe I'll pick a different one. And what you'll notice about these machines is, for the most part, they're not very tall. Like there's no work area. So if you put like a long cutter, you find you can't suck it up far enough. So if you start putting layers of stuff on there for your fixturing of your work holding, you're going to run out of space on a tiny machine like this. So you just have to be a little. There's a small budget for space. I'll pick a different machine just so you can get a sense of what you're dealing with there.
You can move the motor itself up a little bit.
Yeah, exactly. Oh, here's the one with the terrible spindle as well. You see that?
Yeah.
My God.
Don't get this. Yeah. What you want ideally is the ER11 type where they have actually installed it. And it's not installed with grub screws. It's installed with heat. So it's a press fit. So they'll take a blowtorch and they'll heat that thing and they'll slide it on the front of the motor, and then it'll cool itself down. And you have less run out and less issues with that. So even buying, see, okay, here they're showing it off the side. I bought a machine once that showed like this, but this thing came installed, so I was good. I bought two of these, but that's why I said I bought two of these machines. That's how much I like them. But yeah, so that's about it. They're really easy to put together, like 2 to 3 hours if you're really on it. And so what I'm thinking is, if everyone wants to buy this or a smaller or whatever, I'm not talking about a group buy in the sense that one person's going to put out a whole bunch of money and then become like a secretary and try to gather it all from everybody. I don't mean that. I mean that we'll all kind of help each other, and we'll say, these are the types of machine I'm thinking are a good buy, and this is what I'm kind of advocating for because it's low barrier to entry. And then what I'm going to do is we'll host some build parties. So a bunch of people get these, we'll hang out, drink some beer, put the parts together, and then some parties to get them running. And I've already got a workshop I'm planning on how to carve up these fancy blocks for doing printing. That's a fun application. And hopefully maybe Ray has something, maybe Doug will have something to share. So anybody who goes along with this, what you're going to get is you're going to be up and running with a CNC pretty fast without putting out too much money and low risk. Because, let's say, oh, damn it, I hate CNC. You post it in our group and somebody probably in our group will pick it up, you know? Yeah. I'm not guaranteeing that. Like, it's just that for what you're getting here, the amazing stuff that you can get done, I just think it's a good angle to go on, life. So,
Darcy, I have a question.
Yeah.
Without going into a lot of detail, I've had some contact with a very crude, cheap CNC machine that the tech of the museum bought, where it was totally fell down. Not in the mechanical. Well, the mechanical part was pretty crappy, but what was really terrible was the electronics was terrible. There's it gave no thought at all to what you've got the CNC, the stepper motors, where they went into some goddamn amateur piece of electronics, which is very hard to put together. What have these guys done in that respect?
You mean, how are these architected electronically?
Exactly.
Okay, all it is, and I'll just look for board. I'll say CNC 3018, just because that's like the buzzword around this thing. Yeah. And I'll look for the word board, okay? And you'll see what the circuit board of this thing looks like. And there they are. There's a few varieties. You can see this one's got three little drivers at the bottom. This one's got them at the top. They're all very different, but they're all kind of the same too. So
where are these?
Everywhere. We eat.
No, I mean on the machine. Where are they in the machine?
Oh, on the machine. They are sitting right there. So you have the option. So they're basically bolted down against these back two rails, and you can put it anywhere along here you want.
Okay.
Yeah, so, and they consist of 3 of these little Polulu drivers, which you can
Yes.
see here. And so each stepper plugs here, here, and here
Okay.
in a nutshell. Oh, here, and well, anyway, you put 3 of them on there somehow.
Yep. Yep.
And then there's your spindle. And these little boards also have a little speed control for your little spindle. So when you start your little job,
Oh, okay.
a little spindle goes, and then the machine goes around, does its business, and then the spindle shuts off at the end. Okay, so that's cute. And also, there's an Arduino in here. I'm looking around. That's probably your Arduino right there.
Yeah.
So this is an Arduino with 3 stepper controllers wired to it, and with a power circuit to run the DC motor. And there, additionally, you will find most of these boards have also an outlet for a laser.
Okay.
So almost all these boards, it's the same story. You know, you plug your computer to the USB, you put power here to get the spindle and the steppers up going.
Okay.
Mine doesn't have a switch, for example. You know, neither of mine do. So they're, you know, each year they'll make a new one. And then you just plug your spindle in here and go get busy. And if you come with a laser, then you'll unplug your spindle and plug your laser in instead. Put your safety goggles on. I'm afraid of those lasers. I've got one, but I've never used it. I'm too afraid of it. And you just do your business from there. And there's all these extra pins that if you want them, like if you want to do like a probe, you know, go around probing the surface to see if it's level, and then adjusting your G code to follow the contours. You want to make a circuit board like that. I've used the probing on these machines. It does work beautifully. And you can, if you want to have XYZ limit switches so the machines can self-home, they don't usually come with that. You could, but all the pinout is there for that. So that's your architecture. And another beautiful thing why I personally like these as a portable, fun machine is they run off of a laptop brick. Okay. So if I close this, I don't know if you're going to see that in here. So the whole machine is everything you're looking at right there. And all there is to tether off of this thing is one line that runs from the USB to your computer, and another line that runs to just a brick you plug in the wall, like a laptop type brick. And the whole thing, you know, just you can walk down the street with it. It's a lovely portable kit.
Darcy, sorry, I'm not familiar with exactly what you're talking about here. The what's the power supply? You said there's a place to connect the power. What?
Yeah. What voltage and current?
Oh, what does it take? 24 volts and current. You know, you're running 4 steppers and a little spindly do. I'll look at mine right here. I got so here's my brick. That's the wires I got right here. I'm just gonna look for my glasses here, turn on some light, and I'll tell you what this thing says for power. So any 24 volt, right? If you had a lab supply with 24 volts, you wouldn't need this, right? I'm looking at mine now, and it says model input 100 240 1.3 amps input at 120 volts.
Okay.
24 volts, 5 amps.
Sorry, quit screen. Turn off the screen share so we can have closer look. Okay, put up the camera.
Yeah.
Okay. Oh, okay.
Brick. Yeah, so it's just a brick, you know. It's just 5. It says 5. It says, what does it say again? 24 volts, 5 amps.
Okay.
Use any old 5 volt or 24 volt supply.
Okay.
And they went with 24 because that gives you enough. Because those little motors run nice off 24 volts.
Okay.
You know, so they probably have like a buck converter inside there that knocks it down to run the Arduino off of this thing.
So just to review,
the stepper drivers, whatever they're running, they're probably running 24 for all I know. I don't know.
Just to review, Darcy. So we're talking about the machine with a controller board mounted on the gantry of the machine.
Yeah.
And there's a power supply which you just had. That plugs into the wall. Then that power supply goes up to the controller board.
Yeah.
Then there's a USB cable running from there over to your computer. What's the computer running?
The computer. Well, these little Arduino systems that these things have, like most small CNCs, are running Gerbl, GRBL.
Yeah.
No one knows how to pronounce it. or why it's called Gerbil. That's part of the design. So some people say garble, gerbil, gibble. It's important you say it differently each time. You keep your audience confused, and it makes it sound like you know more about what you're talking about. Okay. So anyway, it's called Gerbil. So there's Gerbil firmware already installed on these things. That's the Arduino firmware that's in there. And then on your laptop computer,
on the controller. On
Yeah.
the controller. Okay.
on your laptop computer, you need any Gerbil client.
So you
Now,
need what?
Gerbil client, a client that will talk to the Gerbil
Okay.
firmware in it. And these things, most of the people I think are running the Candle client. Mine came with the Candle on a little CD, and you can download Candle. So Candle is just a Gerbil client that can stream your G code or your commands to the machine.
Okay.
Your workflow, are you usually doing like Fusion 360 and then the Candle client?
Yeah.
And that's
Exactly.
all you need?
Yeah, so like I'm new to Fusion 360, just like many of the people here, but there's lots of workflows. Like for example, to make the lovely little stamp that I made, I used Inkscape to design that because Fusion 360
Okay.
isn't designed for doing like say
So
vector work,
you
like
can
like
do like
Illustrator.
Inkscape, Candle, that will work?
Yeah. Well, yeah. So
okay.
here's what I would do to make that actual thing. So I'm here in Inkscape, and so I found this on the internet. This is a very famous piece of print work that was done by a Japanese printmaker, and I think it was done around 1905 or something like that. That's a JPEG that I found. In Inkscape, I could go path,
Do
trace.
you think
You're not sharing your screen?
Thank you. Okay, so here's a JPEG that I found on the internet of this lovely print. I think it's a beautiful print because it's just two plates, and it just still has so much depth and to it. And so I would just simply take this JPEG, and I will go in Inkscape here, path, trace, preview, and there's my first plate already ready to go.
Wow.
Because it traced it. It converts the JPEG, and this is something that Inkscape can do. And then I'll just say OK. And as you can see, when I exit here, that is a vector image now that I can work with. Now I'm going to trace it again. Path, trace the bitmap. Now I'm going to change the sensitivity so that I'm only seeing the hair. And then I will ask for the removal of the specks that are any smaller than that. And then I'll say, OK. I think I said OK. And then close it. I may have done this twice. No, there's the hair. So I pick this one. I pick a lovely shade for that. So let's go with this blue. Ooh, that's no good. Maybe we'll tune it up there like that. And you see, now I can put down one ink stamp and then another ink stamp. Ooh, better move it on the top page up. Now I just have to slap that on there to make sure that it's roughly lined up. And there's your print, you see? So this is the first design phase that I happen to have done in Inkscape. And then to make it maybe work a little nicer, I'll make a square and I'll take the fill and put a stroke on that. Now Inkscape's another thing to learn. But I can do this to make a fence. So this could become the outside cut where I'm going to actually cut the block out. So this becomes my printing block like that. And then I would then save this file and go from here. Now, some people would make their G code right in here. Now, these machines run G code. Almost all CNC machines run this stuff. And so I have to convert this to a CNC, format. Some people, and I don't do this, will go to extensions, and then you see G code tools. You can sort out all this stuff. This will create the text file that you load directly onto your CNC machine. But I'm using a third-party product that happens to be called VCarve Pro. And that's just what I'm using myself. And so, you would open the file in here. And actually, why don't I open a file? Let's say I want to cut this piece out that I have. Where is it here? There. Let's say this is my final work, and I'm going to you know, I want to make this plate. Well, just to make my life a little bit simpler, I'm going to do the document properties here. Select this. And this document properties lets me make the document be the size of that item right here, there. So there's a button here. And now I don't know where that other circle came. Oh, I got to go. I see. I want to be on this arrow, then select, get that off of there. I want to select this and then say resize. You see what's happening? This is my whole document now. And then I'll go file, save as copy, and maybe I'll push it out to a, either like this, and I'll put it on my desktop. You can put it as a PDF or just leave it as an SVG and it'll probably be okay. So just leave it on the desktop. Now I'll close that guy. And I just created a new file in my desktop, as you can see. I just focused on just the, oh. Oh yeah, I forgot to delete everything else. But in any case, the outline of my document is right around here. And the next stage of the process will know that. So I'm going to take this file that I just made in Inkscape right here and bring it over to my VCarve Pro. And this is, you know, a personal thing. Everyone will have their own G-code method. Fusion can do this as well. And I just haven't done this exact job in Fusion before. That's up next for me to figure out how I can do this particular job in Fusion. I saw a YouTube video the other day, but I haven't tried it yet. So in here, there's lots of options here. Like this little option right here says, when I start the job on the machine, the little pointy thing that's going to cut, it'll be at the lower left of my workpiece. So I'm selecting where my 0, 0 is in my eventual work. And I'll say, okay. Now there's the work. You can see it's white. Now in this software, the left side is a CAD side and the right side is CAM. So I'm going to go over to the CAM side over here, and these are all the different tool operations. And so what I'll pick, like just to be simple here, let's say I have some nice, cute little tiny pointy cutters, right? Like maybe I've got a 132 size cutter on hand. Well, I would just pick one of these tool paths up here to do that. Now the hair, I'm not going to do this time because that's the second plate. So I'm just doing everything but the hair. I want to clear away everything that's sort of starting right in here, all those lines, basically. So everything that's inside this outer square, I want to clear until it reaches another line. That's called pocket. There's a pocket operation. And if I want to do really fine work, I could put a pointy bit on called a V-carve, like a V-shaped bit, and then you choose the V up over here. And it'll actually make up like a tool path for the machine to follow to do the work. So in this particular type of work, I already know what to do. You just select everything and you pick the V for V-carve. Now I happen to have a V bit that is 1/8 inch. So it's already been pre-selected. It can be a tool library over here. Keep like library there of all the tools that you keep on hand so that you can assign the tool to a job. And that once that's done, I would just hit pick all the options here, but I'll just calculate that thing. Continue. And there it is. There's the little V-carve. This is the path it's going to follow. So I can put this at an angle like that. And you can see that it's going to remove all the material. What's that, Ray?
What's the time on that?
Oh, for the time, let's see, I'll go over this. And there's a time button right here. You hit this button and we are looking at 53 minutes. But this is assuming a certain feed rate. So you'll notice that in the V-carve, there's an edit here. This is assuming I'm going at 40 inches a minute as a speed. And I put that'll be my own business, you know, what you put in there. Some machines can go faster than others. These little guys are pretty fast if you tune them up after you get them. And just as fast as any of the other larger machines, because you've seen 3D printers, they can whip around, right? Same thing. And it's because it's the same technology as a 3D printer. So it's based on that. So you could put a bigger number there and say, oh, well, why don't we try 70 inches a minute? And then come back and calculate that again. And then when I close and go find that button again, whoops, wrong button. I don't know what that does. So I'm going to hit escape and pray that it goes away. That worked.
Yeah.
Now we're down to 31 minutes. But if you're really in a rush, to get things done, on the toolpath, which I made here, there's an option here where I can say, use a bigger cutter to clear the big areas, and then use a fine cutter to get the fine areas. And the big cutter will take no time, because it's bigger. So use a clearance tool. Select a tool for that, and you could pick like a bigger, fatter tool, like a 1/8 or a 1/16 instead of the pointy V-shaped one. And I'll pick like I don't know, I think this is a 1/16 tool, the one that I picked, and I'll tell you why I picked it. I could pick a bigger one, it would be faster, but the tinier one doesn't kick up as much dust. So it just sits there and the dust just stays on the spot. And I got a cardboard box I can put around it as well, or you can put it on your back picnic table or what have you. But anyway, so from here, you just select a tool for that. And then now when I calculate it, you'll notice that when we get 2 parts. So when I check and uncheck, so this is the fine work now that will be done by the fine cutter, and it won't take very long, as you can tell by looking at it. Because before it was going to spend a half an hour going back and forth to do her back. But now the bigger cutter is being used for that. And the bigger the cutter you pick for this part, the faster that part will run. And now, so if you feel like changing your cutter in the middle of your job, you can, maybe that takes 1 minute if you get that mastered. Then what you could do is do that, and now you're down to about 15, 16 minutes from 30 minutes, you see? So that'll just be your own kind of, call that you'll make when you do this type of work. Is it, do you feel like changing a cutter, or do you just feel like walking away and having a tea while it's cutting? So that's what your tool chain looks like. So once you get this done, you'll just save this file. It says something's wrong. I don't know why, but because I'm just kind of going quickly, but I'll save that file. And now to run the actual machine, I'll get out of here and I'll open up one of those files with Candle. Now my Candle's sitting around under Active, Art, and then CNC Things, CNC 3018. This is the CD that it came with. And I think everything I need is in one of these folders. It must be download. Here it is, software, and then the Gerbil client. So this is the actual Gerbil client.
And the VCarve Pro, like, it seems a little bit expensive maybe at first. So did you get it right away, or are there other I guess we can do what you do in VCarve Pro, we can do it in Fusion.
Okay, so I think Fusion is going to cover this for us, but I've been doing this for a while, and I happen to be using VCarve Pro because it's pretty good. Now, and I'll tell you that it is expensive software, VCarve Pro, but here's what's happened. We're a makerspace, Hack613. So I managed to fill out the application and got us the privilege of being able to get VCarve Pro at a reduced price. Now, yeah, so I went out and bought it for our makerspace. Now, in terms of the way we run this whole show, what I encountered was no one wants to contribute. So right now I've got the software. In theory, as a makerspace, now there's a couple of technicalities. This license is supposed to be in our makerspace. So I had a physical location on Bank Street, which is 299 Bank. I've since gotten rid of that because there's no one wants to contribute to that, but or the software either. So that's kind of, so I've got it, and I've got 5 seats for 5 CNCs at a maker's space. Now, so where I think we're going to wind up going with this is it'll probably continue that nobody wants to contribute. So I'll probably stop paying. I've been paying for this thing for a while now. And then we'll just use Fusion because it's already free and it'll do the same thing. So I happen to be using it because I got it.
Yeah, for those curious, looking at VCarve Pro, it's $1,000.
I know. Yeah, exactly.
Yeah.
Yeah. So, but the makerspace is only 100. See, so I've been paying I think that comes up to 140 by the time you pay your conversion and your taxes and all that stuff a year for this thing since I got it. And some of the people in our group, when we were in the makerspace, we were using it because that's what the license was for. Technically, we're not supposed to use it outside of the makerspace because otherwise 900 people get it. And but I think what I'm going to do is I'm going to stop paying for this because in our particular group, just the way we're structured, no one gives any money to anybody. And so I'm going to try to figure this out with Fusion so that, and I know it's possible. People do VCarve and it won't be as specialized because VCarve is supremely fine software. I've used it a lot and it's beautiful. But I saw a guy doing a YouTube video and here's what he did. He just took the image like I just did from Inkscape and brought that in there, extruded it up like a little bit, and then that left little channels. And then he went and there's an engrave in the manufacturing area. There's a tool that's the second from the bottom under the 2D and it's called engrave. He went in there and he picked a V-shaped cutter and boom. Even though on the screen it showed as a square channels, but because a V-carve shaped cutter was used, it does the appropriate fine move them up and down. So I just haven't done that yet myself. And yeah, so yeah, you're right. It's expensive software and it's good software. And but there's a ton of options out there on how you can get from your CAD to your CAM. So in 3D printing, we call that process slicing. And in CNC, we call it CAM, And now another really, really nice tool chain is SketchUp. Now, most of us in our group are moving from SketchUp to Fusion, but I should mention you can learn SketchUp really a lot fast. Like you could be up going in no time. Like if I wanted to make something in SketchUp, watch how fast this is. And all the CAD and the CAM is all built into a plugin inside there. It's really lovely. So I'll just look for my SketchUp icon if I can find it in here. I don't know my alphabet, so it always takes me a long while to find.
It's right bottom right.
Yeah. It's red.
Next to the Google.
Oh, there it is. Yeah, thank you very much. There. So we launched that. So this is a SketchUp Make, I believe, the Make edition, I think it's called. It's free. And SketchUp's $1,000, by the way, if you want to get the pro version. And so we start using SketchUp. And then, and that's why I think this bulk buy is a good idea, because we'll all get a machine, we'll all build it together, and then we'll all do our first few jobs together and look at all these different software tool chains. And each person will have their own style of how they, what they want to make and how they want to make it. So there's a guy there. I want to delete the guy. And then I hit the top of the house. So I'm looking down. So let's say I want to make a 1-inch square. So I'll get down here with my pencil. I'll start typing, drawing a line across there, and I'll type 1 inch. So that's now a 1-inch line that I just made. And then I'll come here and I'll type 1 again. And now that I've done that, I can snap to that corner and make my 1-inch square. Done. So then I get the move tool. I'll just shift it like that. So then I go and I use this plugin here. This is a plugin called SketchuCam that's free that you just download and you add it to SketchUp. And it gives you cam ability. So what I'm going to do is first go to the top button. And here I say things like how thick is my material and which cutter am I using, right? So you just fill all this in. This is an overhead gantry and la-di-da. And then you'll come and you'll pick this outside cutter and you say, I want an outside cut on this guy. There. So that is, in fact, a finished product. And if I want to pop a hole in the middle of that, I'll go get the whole circle, put that here, pick the next tool down over here, which is the inside cut, hit that. That's an inside cut hole. That's an outside cut on this outer part. And then from here, there's a green button. You hit this, and it now creates a file. And it's called G-code out, and I'll just put demo. That CNC file now that it just generated, I can go into my the software called Candle, if I can find that little guy. I find Candle. This is candle. This is the machine. This is connected directly to your machine through your USB. You'll be going in service settings and picking the COM port that it's connected to because it's a physical plug-in onto your USB. But you'll just simply do file, open, and you'll grab said file. Mine's on desktop there, and it's called something, I'll put all files because I got a weird extension. And there it is. And so once you've come this far, you'll just be hitting go right there. It's off because my machine is not physically connected. I'll be hitting that button and the spindle will start up and this part will appear before my eyes. So that's what the software tool chain can look like.
Sounds good. One of the reasons I'm interested in that size of CNC is to mill some PCB boards. Is that something that's realistic?
Absolutely. In fact, with this particular machine, and Doug's more of an expert on PCBs, and he's coaching me on how to make circuits and things like that. You can definitely make PCBs on these machines. And there's even a feature in here. I forgot where it is in the buttons over here. And I've tried it and it works beautifully. And you click that feature and you attach like an alligator clip to the cutter and you don't start the spindle. And the machine will go around and it'll probe. Yeah. Okay. And it'll make a map of the surface and then it'll adjust the G code so that, because when you're doing a PCB, you want to cut the exact amount out of there because you're often using a V-carve. So it really is sensitive to variations in the Z axis. Now, one option is just use a square end mill. And then once you're through the copper, you're good. As long as you're low enough to be through the copper, then you're good. But you can get really fine traces if you want to use a V-carve, but then it's Z sensitive. So what people do is they just run a Z probe and it'll go around 25 5x5 probe or whatever you define, and then it'll adjust your G code and it'll follow the contour, even though you built your cutting path on a flat plane. It'll fix that for you. And I've tried it all out and it works like a charm. And so the machine does have enough precision to do that type of work.
So the idea with the alligator clip is you're conducting across the copper.
Absolutely. Right? Yeah, and on that controller that I showed you earlier, there's 2 pins there somewhere and they're labeled. And they're or I don't remember if they're labeled, but I had to research it, I think. And then you just have ground and then another pin. And you just connect one of them to your PCB and the other one to your cutter, and it'll go around and touch the PCB like that.
Okay, well, I'm in. Okay. I guess one thing, when I looked at these before, I quickly got lost because there's just so many of them.
Yeah, I know.
Do you think, like, would you be able to advise on?
I'm kind of afraid to do that because someone buys a bum machine, right?
I know.
When you buy something in eBay or any place, sometimes you have to return things. And so what I'm trying to do here, okay, so is my screen still up? Yeah. So I'll go back to that internet thing. And I'll tell you, if I was buying one right now, I'll show you exactly what I would do, okay? And I've done this twice successfully already. One of the machines arrived with a dead board, you know, the little PCB board. It was dead. So here's what I did. I called back the maker and I said, look, the board's dead. And he says, okay, I'll send you another one. And he did. Now, of course, they're slow. They're coming out of China. So I also went and I bought another board. So I have a spare board right now. So I bought a quick one right away so I would get my machine up and running. And it's just plug and play. I just unscrewed the old board and put the new one on it and plugged it all in and it worked. But anyway, here's what I would do. I use eBay. I always find it's a little cheaper. Mileage will vary in terms of delivery time. So what I would do is I get right here and I would do CNC 3018. And what I'm looking for is the cheapest one that I can find. If it comes quick, that's good too. Like if there's a claim there, it's going to be there. Like depending on how they send it, if it's DHL or something, it's usually just a couple of days. But if it's China Post, you know, then you know where we are now.
Yeah.
But anyway, so me, I had good luck buying this one that's just the frame. I haven't tried one of these yet that has that, but I noticed that they're more expensive. So I would just say, oh, that looks good. That's the first one I saw that's cheap. Oh, wait, this looks better. They're probably the same seller. I'll open them both up. Here, I'll close these other ones to avoid confusion. Now, this is just me, okay? Some people prefer Amazon. Is this the one that I'm on? Yeah, Okay, so these are my first two candidates. So I'm going to click those into a window, and maybe to me that looks a bit much. Although, and when they say USA, sometimes that means you get it quickly. I'll tell you what it also means. It means you're going to get burned by customs.
Yeah.
I get a lot of stuff from China, and it's 50-50 whether they burn you or not. But I come here, I look there, the guy's got 95%. That's pretty low, you know. So he's pissed some people off, obviously. It might not be with this particular product. It's got the ER11. And so this is 182 US. So my damage is going to be, and I just come out here and I do USD to CA or something like that. So this is going to cost me $260 to get in on that one. And so I might look and say, well, I'll forgive him. He's got zone in his name, and hey, you know, I'll just let him have my business. Or I will take the other one, same guy. See, it's the same guy. He's got two of them. They're both free shipping. I don't know what the difference is between that. I'd have to look it over. I think one is anodized and one isn't. So you're paying for anodization. So the heck with that. I'll take this one instead. So now I've got this as my best candidate. I close that. I come back. I keep rolling. Can I do better in price, you know, or can I do better in the rating of the seller? And I just keep going until, well, let's look at his delivery. So that today we're the 17th. So this is claimed to be 10 days to 25 days, right? Or 30 days, 10 to 30 days. So you got to decide how much you're in love with that right there. So, and that's $260. Okay, let's see how our life goes in Amazon. Let's see if, you know, if we get a better delivery.
And you're saying that we should look for ER11.
Yeah, that's the only thing. Just make sure you don't get that other one, the other one that's a non-ER11. Because with the ER11, you can replace the collet and put any diameter that you want inside there. Although most of the cutters you'll wind up using are probably often are going to be 1/8 shank. This is called shank, by the way. The width of the part of the cutter that mounts the machine is called shank. And so
is there anything else besides that we should be looking for?
Well, on these machines, like I just buy the cheapest one. That's just me. And if you go up in price, you can get better rails that, you know, they plug in instead of having extra hardware. I don't know how interesting that is. I haven't tried it yet. And
I've seen some of the boards have got Bluetooth as an option. Have you tried connecting with that and supposed to USB?
I never even thought of that. Yeah, if that's maybe that works, and then you have one less wire on your desk. That sounds good to me. Yeah, I don't know. Like one option I did try is they have this little option called Woodpecker, and you have a little extra box you plug in, and you put an SD card, so that it's untethered from your computer. You write the G code on the little SD card, then you put that on the machine. But then you have to go on the little screen and scroll and look at the little files inside there, and pick the file and then run it. And you don't have as many options. Like when you're running it, you can pause the job, and you know you can do all that, but you're just working on this little tiny screen with little buttons. It's not so nice.
Darcy, I'm getting a little punchy now, so I think I'll say goodbye to everybody. Thanks very much. It's interesting what you're doing here. So see you next week. Okay, bye.
See you next time, Greg. Yeah. So okay, CNC. It is daunting, and that's why I want to do this as a group. Because you know, I just realized you have the same issue we all have when we want to buy one of these things. There's just so much stuff out there, and it's money we're spending, you know. So I'm in here, and let's see how we're doing. See, right away, I'm feeling that it's more expensive because, see, but at least they're quoting me in Canadian dollars, and so there. So if you want to pay another, looks like $50. You get that one, but it's the pro one with all the fancy business. So let's see if we can find. So I'll do my L cheap thing, and there's
also get it next week if you're impatient.
Yeah, if you want it next week. See, there's one that's 300, so that's only $40 more. Let's see what we get for 40. Look at this rating. Okay. So, so 30, 30, I never noticed that they're over 18 on that one axis. Most of the machines are quoted a little high. You're always shy a little bit on one of them.
Yeah.
But, the machine for a full set of spare parts shall I don't understand this.
I don't know. 1 rating, 1 star.
Yeah.
I'll pass on that one.
We don't know if that's the product or if it's the seller.
Yeah.
Let's see what the complaint is. Yeah, but both of them don't speak English, so I don't understand. So,
I noticed some of them
there's
have
that
a
woodpecker I
laser
was-
option.
What's that?
I've noticed some of them have a laser option. Are there any
Yeah.
safe wattages of lasers to use, or are they all even the
Nothing is
lowest?
safe.
Nothing.
No
Okay.
laser.
Big
or
thing about the
stuff is safe.
lasers is the eye protection, and don't trust the goggles that they give you.
Yeah.
Go
That's
for
right.
some high quality goggles, because all it takes is one bad day and you're screwed for life.
Yeah, you'd be deaf before you even know it. You won't even know when it hits you because you can't see it.
Yeah, and it's not going to kill you. It's not going to burn you, but it will destroy your eyesight.
Yeah, your eyesight will
Okay.
be done, and you know it'll start with inflammation, and next thing you know, an hour later, you're gonna
Even
you know
these,
you're losing your vision, and for real, forever. So
these laser diode ones are not sort of conical shaped, so it's safer, or they're just all treat them all as
the
if
same.
they're.
Like, so I think the CNC is more safe above a laser because a laser is more prone to burn your house down, and it's more prone to burn your eyes. And so I'm just sticking me to CNC. I own one of these with a laser as well, and I have another laser, and I got a big 100 watts type laser, like a big, not a desktop, but a full industrial laser, and that stuff scares the daylights out of me. I'm probably going to disadopt even my big laser eventually because I find that CNC can do so much interesting things. So anyway, this one looks quite promising, $259. So we're all the same price we just found in eBay without the offline control. That's the option I tried that I didn't like. Let's see what delivery we're looking for is. June 8th. Not attractive, eh?
Drop ship.
Yeah. So that's June 8th. So that's 50. That's like 2.5 weeks in the future right now. Sometimes it might come sooner. Like when I order stuff, like sometimes I just get it next day. Like sometimes funny stuff happens.
Yeah,
like
Amazon has gotten a lot slower in its delivery
Yeah.
of non-essential items, and that's deliberate
Yeah.
on their part. So I mean, there have been a few things I was looking at that I would get in less than a week before that are now taking over a month.
Yeah,
I
Consider
ordered
this
my
essential.
I ordered my CNC on eBay, and I made sure it had a USA warehouse, and I got my CNC in 36 hours. So that was pretty good. So that was, and I deliberately made sure they had a USA warehouse. I didn't expect it in 36 hours. I just didn't want to have to wait, 40 plus days. But I went, but that's how it turned out.
So this one, you got different choices. Like it looks like if I go here, I get, this is the minimal. See, you've got an ER11 and you get a little disc thing. This probably has your software on it.
Yeah, that one
colors
has
you'll
the
probably never
controller.
use. Pardon?
That one has the controller.
Oh yeah, it has the extra thingamadoodle there, you see. I don't find you need that thing, but hey, we're already at 289. So what's the next
So
one?
one comment on the controller, and I've experienced this with 3D printing as well, is if you have bad connections with your computer, this is one of the things that
to stabilize it.
Yeah, exactly. So if you get a USB connection that like a sloppy cable or something like that, you've got some time, you're waiting for the next command. I don't know how well the gerbil controller will handle that.
Yeah, I don't either. Yeah, I don't. So this one looks like, and I forgot, I don't see where the option is now to get it back to cheap, but it's you see I'm stuck at 350. But if I go buy it or add it, there might be some other shipping options or something, like let's say I go here. I gotta be careful not to buy this by accident here. I'm gonna buy it by accident. I don't know what this all means.
It's if you want to add Prime.
Yeah, I don't want to.
To say no thanks there.
Idea.
Yeah. Oh, there's little smaller ones too. Like 1610 is another tiny. We don't want to be tiny. There you go. And I find that be good, like the 1610 Pro. Let's say take that. So 1610, knowing that that's a good size, you put 1610 on here. That's half the size, eh? That's a quarter in area wise. The price isn't coming down that much, eh?
Yeah, because you got a bare minimum of stuff. All you're saving is just a couple
bit of extruded material. Exactly the same, parts, everything, free shipping. You'll have that in a while, 2 weeks, 2 to 3, 4 weeks type thing. It's half assembled. You can see parts that hanging out there. Some of these guys that sell them, they don't make them. They're just resellers. But
what's the next size up?
I don't know. There's one that's got 24 in it, like CNC something 24. Or there's if 2418. There's another size. And like you can make one any size in theory, but I think some of this is to do with some like the different rods coming. You know, some like there'll be some part that's in there that influences the price, you know, and there'll be some particular sizes that come forward, you know, because of just the way parts are made. And yeah, see there's $125 and you're in the game with a tiny machine. That'll probably make your PCBs no problem. 24 centimeters by 18 centimeter work area. Oh wait, $75. Get the thing, you know.
Yeah, you always got to watch out for the shipping on that.
Yeah. So that's why I didn't want to do like a real bulk buy where maybe I have to now collect money from everyone, because now we have to have it that everyone's going to be different. Like some people know I want it next week, and some people no, I'm going to save $100 and I'll have mine in 3 weeks. So I was going to leave that to everybody, and because I don't really know how to solve that problem without exposing myself to being blamed for something went wrong. And I mean, I have good results when I buy these things. Like I had a dead controller once. Well, the first CNC machine I ever bought arrived dead. That was my first big investment, and I just replaced all the electrical on it with American-made CNC controller and steppers, the whole thing. I just pulled it, and the seller actually sent me all the parts, so that was good. It's just that to avoid the delay, I put all American stuff on it. I was able to drive down to have it shipped to Ogdensburg, and then drive to Ogdensburg, pick it up. And so the electrical only cost me $410 plus tax. And I was happy with that. But yeah, so I think everyone is their own, you know, person around how I want it now. I want it in 1 week. But so in terms of all the options, I'm suggesting that 3018 is a good size. It seems to be a price step there. You know, if you go past it, it changes to structure of the machine, becomes very heavy and no longer as portable and easy and low priced. And then if you go down from there, the price doesn't seem to drop enough to make up for the fact that you're getting a smaller machine. And that's all in the material economy of all the materials in the machine.
If there was a slightly bigger one that could cut like an aluminum box a little more comfortably, that would be a plus for me. If it didn't,
yeah, when I saw your box, yeah, I thought of that. So like maybe like.
Yeah, but that's something you can cut in sections. So if you have a longer sheet, at least you can have a sheet hanging off the work area here. So you can like break it up into sections and do one section at a time.
It's like an already
longer, but the alternative.
Like an already assembled box.
And spindle wattage.
It's an already assembled Hammond enclosure.
Yeah. That's more. And even if you get a bigger machine, okay, check this out. Let's say we look at a big machine. You can have lots of workspace under it, like where the spindle is high enough up that you can put a box underneath it. So these 6090s start having some really high rising. The spindles are really up there. So I'll do CNC 6090.
I'm going to have to go do some other stuff. But I guess our next step is like we look for machines.
So everyone now, so we can do another session to somehow, like if you want, you can pick a machine or two, send it to me, or we'll book another of these sessions anytime, and I'll do my best to try to help to make sure you don't catch something by.
Okay.
You know what I mean? Good. I'll give you the best help I can. So when do you want to book the next? Do you want to leave it till the next weekend, or do you want to do a session this week?
Maybe an evening. I mean, I work in the daytime, but nights are good. Like Tuesdays are good. Tuesday or Thursday evening.
How about Tuesday 8:30?
Yeah, that sounds perfect.
Okay.
I just caught myself trying to scroll your browser, Darcy.
Too much excitement looking at these 6090s. Okay, put something in the calendar for that, and we'll talk. I'll post it to everybody so we can all get in there and say, this is what I'm going to buy. What do you think? Okay.
That sounds great. Okay.
See you, Isabel.
Talk to you guys soon. Bye.
Yeah.
Bye-bye.
So there's your entry level 6090, and I'll tell you what's wrong with it. The rails. Now in this picture, I already know that the picture is misleading because of the price. They're showing round rail at the bottom, but when you get this, it's not going to be that. They just got some other pictures. They're going to be rails like that, okay, that are not as stable as the supported rail. Because see, they're showing supported rail, but this thing's going to come with round rail everywhere. I'm pretty sure of that. And the picture doesn't even look like a 60. That's not even a 6090 they're showing. So this is a bogus listing of some kind. They got 100%. I don't know what's going on, but it scares the hell out of me. 6090, maybe it is. Oh, there it is in Canadian. But when I clicked it, it was only, okay, that's US, and then that's your Canadian. So you're looking at 3,500 minimum, 3,700 entry level for this machine, right? But you're starting to get some higher. You got this space. Here's what you're looking at. You're trying to get over 10 centimeters finally. When you get to this size of machine, you're going to get 10 centimeters, even 20 centimeters if you get a nice one. I've seen these machines like this one, you're going up in price, another cheap one.
That's a little over the budget there.
Yeah, that's getting crazy. But they're sweetheart machine, these. But here's the problem with buying a 6090. They're heavy, okay? Unless you buy a cheap one, if you buy a cheap one, it'll go DHL. But if you buy one of these that's not cheap, it won't go DHL. It's over DHL's limit. So that means if you buy it, DHL won't touch it and Canada Post won't touch it. Okay? That means they're going to ship it to the nearest port, and you'll have to do logistics from the port. You're going to pay fees for, all that. It has to go to a container port, basically, and the Port of Montreal is the closest one. And that's going to be some more cost to factor into this thing. I went through that once when I bought my laser cutter, and recently I tried to buy one of these 6090s, and I couldn't even get the guys to quote me to my door. They just said, we'll go to Montreal, and after that's your problem. That's the best I could come up with. And these days, the logistics are more solvable. Like there's companies that take care of this. There's some of these 6090s that have really high, here's a look pretty high one. You see that? Even the gantry comes up pretty high. These ones come from Europe, actually. When you see this color, they're usually from Europe, and then this color usually come from China. Although they're sold out of Europe, but they might be made in China. I don't know. Okay, so yeah, so when you get to this, that's going to be a challenge because most CNC machines are designed for cutting sheets. Okay, there's another kind that's designed for cutting blocks or billets, and they're called an upright. So if we look for a CNC upright, they have some of those. Like a 3040 comes in an upright. Let's see if we can find that CNC 3040 upright. That doesn't mean we're going to have enough clearance, but they tend to have more clearance. If I can find one, it doesn't look like
the clearance on the 3018.
What's that?
What was the clearance on the 3018 you were talking about?
Oh, it's pretty small. Here, I'll just get my
like
machine.
4.5 centimeters was the one we came
4.5, yeah.
Okay.
It seems to be one of the very few common designs.
Yeah, so on this machine, and I got it right here. I'm just looking at it. And I don't know if you can see this on my camera or not. The distance between this bottom face of the truck that rides the gantry and your bed, that's your distance. And on mine, it looks to me like, where's my little measuring thing?
And if you have like a cut through layer, like a block of wood underneath your aluminum, that adds.
Yeah.
And all that.
So this thing is, looks like 6 centimeters. I got 6 centimeters on that thing. Now there's another thing to think about, and some machines can reach over their front edge. Now I'll just get my my CNC cam here, and I'll turn my share off for a second so it's easier to see my CNC cam. So this is my CNC cam. I'm gonna walk over that machine. Now if I bring this forward, and I can't right now, well, I guess I could turn it on, but there's too much stuff piled on it. But if you look at this machine right here, and I got my cutter right here, you can see that, right? This is the cutter. Now when I jog this thing forward like this, what this machine will do, like most, it'll reach over the front. I can cut something out here on this machine.
Oh, I see.
So I could clamp something right here and cut the end of it. But this machine doesn't reach very far. It only reaches like about a centimeter plus outside of the front. But my other machine that's in my other lab across town, it can reach like 2.5 centimeters out. So Doug and I have been discussing, you know, another topology of a machine where you could just build a machine with that in thought. And then you have two options. You can strap on your bed, or you can strap something to the front and face mill on something. So there could be something to think about along those lines.
So realistically, if I were looking at a bigger print area, I'd be looking at something like the 3D printed CNC, where it's basically using the pipe.
Yeah. Now I don't. You probably want to have some before considering that. You probably want to try, and it's a shame because like we used to have a space on Bank Street. You could come in there. We had CNCs all over the place. You could try them out and get a sense. What I think will happen with those mostly 3D printed ones, I think they're not very rigid. And
well, for what I need, it's not that, like I'm cutting just rings and stuff like that. So for me, that'd be fine. I'm not milling like super big chunks of aluminum or anything like that.
Yeah, you really want to see this stuff in action because there's a lot of little parameters in there. Like one of the things that I've dismissed is like a lot of people get like a cheap CNC, like a Dremel on it. And the idea is, oh, I got a Dremel. I already got that. I'm saving money.
Yeah.
Those things are so noisy. They're full of run out and they wobble and they vibrate and they howl. You'll get a headache out of that thing. Like I had a CNC with a Dremel on it, and I got to tell you, I've never been the same after running that thing.
Those things are loud.
And yeah, it's a Dremel. You see in practice, oh, a Dremel, it's a cutter, but the requirements for this type of work. So a CNC normal spindle, they got, you know, they don't have run out. Like they don't jiggle and vibrate. They're very low on run out. And a Dremel does not meet that requirement. The only reason these little motors work is because they've got nice tight, I'm sure they're brass bushings in there, and that seems to be okay. Seems to get, you know, something reasonable. And obviously there's going to be some, you know, you'll be buying if you're using this thing a lot, you'll probably be spending $15 on another motor sooner or later. These spindles will last a decade, you know, like, or more. Like I've got my first spindle burned out, like it was 9 years old when my first spindle went. That's 9 years of a lot of use. And that was a brush spindle. And everything now I have is all brushless. So that's one less thing to break. Now I'm only up against bearings and electrical, if I can fry that.
With these 3018s, they generally brush motors?
Like a 12-inch ring like this with 3-inch hole in the middle and then 8 concentric 3-inch holes all around it. And I cut that with a router and a circle jig. So, I mean, that took me probably about 4 hours all included. I had to cut 3 of those. So yeah, that was a lot of time.
Yeah. So Duncan's got a tricky problem because he wants a big object, you know, that, you know, so you could almost, here's a thought, okay? Now, so you're doing it sort of commercially and it's kind of a hobby, I'm sure too, but what if you, let's just what if you made a machine, you know, like you take like a 3018 and you just modify that so that it's got tall little legs and that little bed there, you just make everything taller and you make space in there, you know?
Oh, show me the 3018 again. Isn't that just extrusions on the?
Yeah, it's just a bunch of extrusions. So you could buy that. Yeah. Here, I'll put the my share back on, and then I'll put it back on 3018 here.
I could always have like a machine shop.
No, not even a machine shop. You can buy those extrusions online and cut them to length.
Yeah, that's.
I mean, like the box, like to cut the box itself, I could always have like one of those other places or a shop, like cut a whole bunch of the boxes and then use the CNC for smaller stuff.
Yeah, you could do that too.
If the CNC suddenly becomes way less feasible just for that one project.
Did you invest in a bunch of those boxes, like, and you're stuck to that? Because sometimes, like, you might say there are different boxes that might give you more options. Like some boxes, the back comes out and then you machine that and you stick it back in. Like some boxes come apart, some don't. You know, there's that too to think about.
What about giving it more Z-axis? Like there's the 2 round rails and so on like that. Yeah, could you not change that to give you more?
If you just change the extrusions on the side, I mean, you can buy 3018 rail and make those long.
Yeah, you see that right there, that extrusion there? You could take this machine and just replace those two parts, and it can be this tall if you want.
Yeah, but you're still only going to have the same amount of Z-axis move.
That's right, but that's all you need for cutting your the part. Then you take your big extrusions off, you put the short ones back on, you're back in business.
Or even just put some sort of spacer underneath a small box to bring it up to height for the more stuff.
With some types of tables, for example, with a movable gantry, the head will go over the edge, and
that's
so
what I was showing earlier. Yeah.
Oh, okay.
Yeah.
So you could just clamp on from the side and do larger objects that way.
Then you just extend the spindle outward.
But you still only have that plunge. You only have that much plunge, no matter what you do.
Yeah.
Well, I think that's probably fixable too, right? If you just that U-shaped part that's holding the spindle on.
Yeah.
The length of your tool is going to be an issue.
Pardon?
The length of your tool is going to be an issue. So it doesn't matter how much Z you have. If your cutters only can be so long before they flex and break, then that you've got limits.
No, but when he's going to cut a thick piece, he's not going to cut all the way through. He's only going to cut 2 millimeters into it, or 5 tops, because he's got a box. He just wants to cut holes in it. Like it could be also like Dan said it earlier about punching, right? There's probably a punch that you can buy that punches out some of the shapes that you need, like a pliers. You know what I mean? Like a hole punch. Maybe that exists.
Or use a Donnie Boone.
If there's standard parts, then there could be something like that. Like if I'm punching a hole for a standard IEC outlet.
Yeah, there might be a punch.
There definitely is.
Yeah, that won't be cheap though.
No, because they're hard steel, right? And
yeah, exactly.
Yeah,
that's going to be tool steel, you know, and it's going to be probably as much as one of these machines. I wouldn't be surprised if you got the punches are going to cost as much as this, and then you don't have the flexibility. Like CNC doesn't solve everything, but it sure solves a lot of stuff. If you're willing to refactor your work around the machine a little, you can really.
A lot of it does depend on what precision you require too.
Yeah.
For a punch, even like there's a lot of little holes to drill on the thing, which like I guess it's not hard just to drill a hole, but when you measure them all out and try to put them exactly where you want them, then it takes a lot of beauty.
Yeah.
For me, a 3018 is a good size, but I see there's other sizes, the 4018 and the 4030 as well. If that's
I haven't
might
seen
fit your. Reddit had a mention of it, so I went to AliExpress. They had some listed.
Yeah. Okay, let me look. So CNC 4018. Let's look at that.
And then 4030, but that gets in the $1,500 range.
4030. Okay.
There's
I couldn't
probably
find a 4018.
Parts I could make.
3040, yeah. They call it, usually they say 3040 for some reason, yeah. That's why I didn't ring a bell. I don't know.
That gets up to about 1,000.
Yeah. Ray picked one up on it.
Physically too big for me. And those are not your standard little brushed motors as well. Looks like a proper spindle.
Well, you get
shipping is crazy expensive though.
3040, you tend to get a DC spindle still. They're okay though,
Air cooled.
They'll last a little bit. I've had 2 of those before on different machines. And, like for me, like CNC's become like almost like a way of life, like I've gone crazy over it. So I've reached the point where I realized, I can pay a little bit more to get a brushless. It'll just keep on going forever. I won't have to change the brushes or anything like that. So when I buy new stuff now, I mainly will buy brushless motors. But something like these little 3018s, they're so inexpensive. I don't really feel a problem there. Like I'm okay if I blow off a $15 motor once in a while, and I'll just brag about that. I don't see that as it's kind of a portable machine. It's not going to carry my full workload of everything. So I could probably live with if I blew a motor, and I haven't yet. I haven't been able to use it enough to have any noticeable wear on the motors, or the motor, I mean.
Probably a lot of smaller stuff I could build on one of these too. Like there's a lot of like common little plastic parts and the old turntables that break, and if I can design those and then print a bunch of them, that's something I can even sell a bunch of.
In theory, yeah.
And those don't need any big machines.
Yeah, so small parts, yeah.
And just
And
even circuit boards for a few
like
parts.
like when you buy a machine, like I think one idea is you just buy the machine you need of your life, right? But you don't know what that is. So that's why I'm thinking that this is a good project for most people, because you can get something and just upgrade later. You get another machine.
Yeah.
What are you gonna do with your 3018? Either keep it or sell it, right?
Yeah.
Sell it, you'll get most of your money back or a good chunk of it. And so you're not, say you had it, you had it a year or something, and you could at the end of that, you could say, well, I know all about CNC now. Now I feel confident. Now I know I need a 69 here. Now I know I need an upright mill. Now I know, like you kind of would be ready to make a bigger purchase after, maybe that would have more impact on your life. This thing.
There are other aspects.
What's that?
Even with 3D printing, I could use a bigger 3D printer because I have big pieces to print. But most of the stuff I need to print isn't big.
Yeah.
So I could use the other one as just for the small parts, and then use the bigger one for the big parts.
Yeah. So when you go to make a part, if one machine's busy, just go to the next machine. Yeah. Then because 3D printing takes really long. It's really nice to have probably more than one 3D printer.
Can I ask you two questions, Darcy?
Yeah.
One is dust control, and the other one is noise level.
Okay. Now, on dust, it depends what you're doing. Like if Doug was here, he would tell you he just doesn't bother much with wood. He cuts a lot of HDPE, like high density polyethylene, and it doesn't make dust. It makes chips that don't float in the air. They stay on site. So you could just pick those chips up, so he doesn't feel that there's any. Me, I cut lots of hardboard, which is nasty for dust.
Yeah.
So I recently made like a vacuum attachment so I can suck the thing up all the time. And I noticed recently when using it, I don't even smell dust in the room. Because when I use a CNC, they do generate, depending on the type of job, you will notice all of a sudden there's dust settling everywhere. And
Right.
that, you don't want that. So some people will, and I made a box that goes around my 3018. And I think the easiest way to show it is, I think I have it on my website, and I think I do. Let me check that. Inventor Art. I haven't been updating my website very much lately. Yeah, I do have it on my website. So here, I'll just throw that up, and you can see. And this, I think, would solve the problem 100%. And here's what it looks like. So this guy right here. So I just got a piece of cardboard, and you can see it right there. What? I can't click this. This is rude. Oh, a crappy website. I got to fix that. Okay. So you see what I've done here? I've just taken some piece of cardboard.
Yeah.
And now the front of this will open, as you can see, like this. Try to zoom that a little.
I imagine it cuts down on the sound as well.
I didn't notice, but
no.
Yeah. So you see, there's like an indexer right there. This piece sticks in the front, and all the pieces that are flying around and everything. Like I'm cutting CDs on this, as you can tell. I make earrings and stuff out of CDs, and it's just shooting out all the little parts as it's got a little piece of CD flying out. So there's no dust with this problem, but it just pitches all these little. They go as far as, I would say, maybe that far. And the occasional one is a little further out. So you just wind up having a vacuum all around it. It's kind of annoying. So this, no problem. It does not happen. And if you put a top over it, like a clear shower curtain, that'll keep all the dust inside. So let it do its business. It'll stop. It'll all settle. Scoop it in the garbage, and you're done. So I won't say there's no dust. It depends what you're doing. You can put vacuum thing on there, or you could just do this, or garage, or picnic table in the backyard if you have that type of thing. Okay, so. Yeah, dust is a concern. You have to do something about it, or you're just not cutting. Just don't cut things that make dust.
Right.
And then the other item was noise. I noticed like my 6040 out in the West End there in my other lab, it doesn't make any sound. It doesn't matter what I do. It's cutting. It make no sound. Once in a while, I'll put a large cutter on it, and I'll cut some hardwood or a piece of that particle board, and it'll howl like crazy. But most of the time, it's quiet. I don't know what it is. It's a quiet machine. It's something to do with the spindle and the construction of the machine. But this cheap 6040 I have here, when you're cutting wood, it howls. Okay. So I just so I have to I try to be nice about when I run it. But when I'm not being nice, I just put my headphones on and that's it.
I find the vacuum cleaners noisy.
Yeah, the vacuum cleaner is still noisier.
Okay. Yeah, so it's not like people on another floor of the house couldn't be watching TV or something.
Oh, no, no, something like that.
They'll hear the
I'm
vacuum
gonna
cleaner.
sign out.
Okay,
right.
See you later then, Duncan.
Yeah.
See you.
Bye.
Whoops, I was trying to click the X on your screen. Yeah.
What's that?
People keep trying to mouse onto your screen.
Oh,
I
you
was
keep trying to use my
the X
screen.
on your screen, and it was from your
Yeah, I just took it away so it wouldn't be so confusing.
Yeah, there.
There. Yeah, so these are real concerns, but I found that for the value of these machines is so high, I'm ready to take on all that stuff. Out in my West End, you know how I work dealing with dust? The CNC machine's got a dedicated room and I close the door.
Oh, okay. Well, that works too.
Yeah, I go in there once in a while and I shovel the dust off the floor.
Really, that much of it?
Yeah. I've had to shovel it. That's how bad. Because that's a lot of empty and vacuum. I just say let it lie where it lies, and you just pick it up.
Yeah, exactly.
And that's a perfectly that works.
Cool.
Oh, and
well, this has been
vacuums
hugely entertaining and informative at the same time. I'm really excited now. I just want to go start shopping and try and figure out which one.
Yeah, I definitely want one. I just have no money.
I can lend you money. I'll lend you money. You want to buy stuff?
No. Down that road leads danger.
Lending, with high interest and
remote access. You wake up in the middle of the night, you'll be making earrings.
So Tuesday night, I'm going to try and have some candidates for Tuesday evening. Then that I'll send you the links. And... Sorry, what was that?
What time are we doing it on Tuesday?
He said 8:30, I think, or 8 o'clock or 8:30. He said you were going to put it on the Hack 613 calendar.
I'll do that now before I forget it. So while we're talking here.
So what's that on
YouTube,
Tuesday?
History and see.
So by Tuesday, some people will have come forward and said, "I think I want to buy this machine. Can you think of a reason I shouldn't buy this machine?"
Right. I like that. That's a good service because I
don't want to put myself in too much a liability situation.
Yeah.
But I do want to give people a bit of help here. There's always risk, but we can try to help each other.
Minimize the risk, yeah.
Yeah, we try to minimize it because I've been through this process a few times. Ray's bought a machine, Doug's got machines. It's a shame Doug had to take off, but because he's a good resource for CNC too. Yeah, so I'm putting that on our
probably
website.
why I don't have one now, because I have been in there looking before, and it's just kind of like, which one do I want? What am I looking for?
Well, and the prices vary so wildly. You think, this looks almost exactly the same. Why is it twice as much money? And you think you're missing something, right?
Yeah, exactly. And sometimes they're just listing it for no reason because they're on vacation and they don't want to be bothered. So rather than take the listing down, there's a lot of funny stuff that happens. But I think I've cooked it down. There's a couple of really good deals out there. And that 3018 seems to be a bit of a sweet spot. Like you're getting a lot of value for very little money.
Yeah.
3040 and the 6040. Those two sizes also have very high value. Like what you pay versus what you're getting seems to be a real sweet spot.
Canadian dollar is a little off right now compared to.
Yeah, that's a bugger. That is nasty.
That's
I know.
probably going to get worse for a little while.
That's why you want to get paid in American dollars.
And
I used to get paid in American dollars.
I love it when the Canadian dollar tanks because, I go to convert it, my paycheck into Canadian and it's like I just got a huge raise. So
yeah,
I tell you, that was the big shock coming back to Canada is just how much more expensive it is to get the same stuff.
Yeah.
Because it's the difference in exchange rates, it's the shipping costs, it's the import taxes. So like one of the main body tube for my Saturn V cost about $100 on their website, and it's $250 by the time I get it in my hands.
Yeah. When I was going back and forth a lot, I would buy a lot of stuff in the States and just bring it back with me on my regular trips. And if it's not new and it belongs to the company anyway, they generally don't give a crap when you cross the border with it. So it's it belongs to the company anyway, and then it can be in my office in Ottawa instead of in the office in New York or whatever. And if it's not brand new equipment, then they don't really care. So, but it was crazy. I mean, I bought an oscilloscope down there that would have been twice as much money to buy the exact same scope in Canada.
Yeah, it's a little bit insane.
It is. There's something going on there that we're getting ripped off, I think, really.
Well, the problem is it's no one thing. It's a combination of many, many things. But.
Yeah. Yeah. Even tires for my car. You talked about going down to Ogdensburg. I put new set of tires on the car and went to Ogdensburg and had them installed down there. Saved a massive amount of money. You know, probably saved me, I don't know, $700 or something like that.
That might work for this project too. You know, you might be able to buy something that, you know, in the USA, and you have it go to Ogdensburg, and you won't see that $70 shipping. It'll be $10 or
yeah.
Yeah. The problem is, no,
see,
you
that's
can't.
what caught me on the body tube. It was like over $100 in shipping.
Yeah.
Yeah. And then so now you got to get to Ogdensburg. That's the problem. Now you're doing logistics to bring it
well,
in.
right now it'd be tough to get to Ogdensburg if you don't have a boat. But
you got to explain to the border police why you're going there. And I you know.
Yeah, they wouldn't. I don't think they'd let you cross right now.
Not for nothing, anyway.
No. But you know, be that it's. I mean, the only thing about the prices when I was just looking here on Amazon look to be a little higher, but with Amazon Prime, some of the deliveries don't look so bad for some of them. It looks like you can get them within a week.
Yeah. So that'll be the trade-off. Like me, I just do it on the cheap, right? Then you have to sit and wait. Oh, my CNC. You know, some other people get it before you. So what I anticipate happening here is we'll start with our build party, you know, maybe as early as 2 weeks from now, because some people will have it. But then those people will lead the next build parties.
Oh, okay. See, if it showed up, I don't think I'd be able to wait for the party to put it together. I'd just be wanting
that's fine. Yeah, good. That's fine.
Yeah, but the party is where you say, okay, I screwed this up. How do I fix it?
Exactly.
Yeah, but also like anybody, if it's your objection, like some people won't buy it because they'll be overwhelmed. But now we just remove that objection, because if somebody can't build it by themselves or they get stuck, like when I got one of these machines had a dead controller. A novice might not know what's wrong with the situation.
Yeah, they'll just assume that's something they did wrong, right?
Yeah, we'll be able to say, no, let's check this. And no, you got a bad controller. I got a spare. It's on its way over. We just got to get another one from your supplier. And then they'll be, you know, that's what we'll be able to do for them.
Yeah, that'll be good. I mean, some people maybe they won't be able to assemble it, and then we can pitch in and help out if they don't have the skills. But it can't. You're just looking at them. It can't be that difficult to assemble.
Yeah.
You know, everything's pre-cut, right? They're not just giving us, you know, lengths of extrusion that need to be cut. Yeah.
It's like Meccano. You're putting screws in there and screwing the whole thing together. When I got the first one, I just thought it was such a cute little machine. I was so excited. The guy showed up at the door, knocked at the door. I took the box, I set it on my table. And 2 hours and 10 minutes or so later, I was jogging it around. I had it running. Wow. The second one I got, I thought, okay, because my friend told me it took him a whole day, and I thought, okay, I'm going to see how fast I can put this together, just so I can brag about it and piss him off. And I put it together as fast as I could, and it took 3 hours. What's wrong? It took me 3 hours. I don't know why. I was fumbling, dropping everything the whole time. I was.
How are the instruction booklets for these? Are they online or?
What's that?
The instruction booklets, are they online or fairly good quality or typical?
I didn't follow it the first time through. I just lined them up. I got 4 of these and 2 of those, and they must be this part because there's only 2 of those things. And I know I got 4. You know, like
it's just pretty straightforward. Yeah.
Yeah, it's just all the same thing, just bolting. Yeah, there's instructions. Usually comes on the CD or on a memory stick that's with it, or they'll email that to you with your purchase. I got that stuff. It's really nothing. It's just a bunch of stuff stuck together, and then there's only one way to plug all the stuff together too.
Great.
It's quite all right.
It looks like there's only 2 different basic designs. I imagine if you pick up from one vendor, you might be able to get an instruction booklet from another one that would match exactly.
I got instructions. I bought 2 of them, so I got my full kit that I got from each of those, both in software, you know, and there. So I think our event is on our website. I should put a picture so it looks pretty. Got to add a set feature image. I'll put a picture of, I don't know, whatever. I'll just pick a random one. I want a picture of that. There, random picture, done. Save it, and then I think it's going to be on our website.
How big a hassle would it be to build a 5 or 6 axis CNC?
I don't know.
Because buying them is just too much, but maybe building it wouldn't be so bad.
But this is okay. This is kind of what this project is about, because a lot of people are to save money, are going to build a CNC, and that could take 20 years before time we actually are doing it, because it's long process, looking for materials, found objects, whatever it takes to build the machine. And at the end game, some of these purchases like this thing, you could go off and order all this stuff, and I bet you'd have a hard time finding all this stuff.
Right.
I think the hard part to find would be the bed. Everything else is pretty
just a piece of extruded aluminum. Yeah, it's a piece of extruded aluminum.
Yeah.
I bet you if you go shop for these 3018s, there's probably 1,000 people that buy up all that stuff and put it together in a kit and get the same circuit board. And they're all it's parts. You're just buying a pile of parts.
Yeah.
Like the guys that sell these, they got a recipe. They're sitting in China. They get on the internet. They get the 3018 recipe. They go to their local market. They get some of this, and they go to that local market. They put that thing together, and they go on eBay. And now they
post them and
so
sell them.
bad. I mean, you can make that out of cement if you wanted to. But it won't move. I mean, it's going to be wherever you put it.
Well, the problem is it's got to be perfectly flat, right?
Well, again, the great thing about the CNC is it can mill something flat, like your bed.
It can mill itself flat too.
Yeah.
Oh, I see what you're saying.
Yeah, it can do that.
Yeah.
So the only problem with the concrete slab is the attach points. So you don't have the
anchors of some
peanut
kind.
slots and things like
How
that.
about a magnetic bed? Like they use on real mills that.
Well, it depends on what you're doing. If you're doing through cuts, that may not be as effective. If you're just doing like etchings and things like that.
Yeah.
Well, a good way to attach things is using painter tape and crazy glue. It holds really, really well. It's surprising.
Double-sided tape.
No, just painter's tape and crazy glue. Painter's tape on both the bed and the object, and then a couple drops of crazy glue. And
Oh, I see. And then you just peel it off afterwards.
And they're cutting steel with this connection. I mean,
oh, that's brilliant. And it takes
doesn't
no
mark
Z axis away from you, right?
then you have almost zero Z. But if you cut through, then you really have a problem because you just cut your bed.
Well, you put a wasteboard underneath.
Yeah,
You got the
that's
rim.
what I do.
Yeah.
And I've been using double-sided tape, but double-sided tape has some compression, but I get it at the dollar store. So again, I'm using painter. I put down the painter's tape just so that I don't end up with the residue, and then I use the double-sided tape. But if I put my hand on it to hold it in place, which is a habit that I have, I compress the double-sided tape, and then I end up with a wobbly line.
Oh.
But if I just go
And
with
a missing finger.
well, it'll cut me a little, but it won't take the whole thing.
Yeah, it's got to be attached to be able to grow back, right?
Oh, wow. I use the crazy glue, right? See, I'm all
Yeah.
set. You know?
Oh, yeah, you got the crazy glue right there. Yeah, just crazy
It
glue
burns
that
a little
finger.
bit, but yeah.
Oh, I didn't know that. I still have them on.
Yeah. Yeah, the medical crazy glue isn't as exothermic as the stuff you use at home. So I have had some deep cuts where I just put a couple of drops in there to close it up. But
Yeah. Well, I'm gonna have to drop off. My boss is pinging me, so I got to go do some work.
Okay.
yeah, I should probably run too. But thanks for this, Darcy.
Right.
This has been like pretty
Pleasure's
awesome.
mine.
Okay.
Very
we'll-
informative, yes.
Yeah, we'll see you on Tuesday evening.
Tuesday night, yeah.
Okay.
Okay, bye-bye.
So I guess you should probably end the live stream. Then.
What's that?
You should
Oh yeah, we
probably-
shut the live streaming off now. Yeah, good point. Thank you for that. Let me just do that.